So, hello everyone, I welcome you all again. So, let's start with today's topic. First, we will revise the previous class with some easy questions. Okay, let's start. So, which is not an irrational number? Tell me, just seeing it, you can tell. Which is not an irrational number in this? Yeah, option number D. Because this will become 6 plus 3, that is equal to 9. Very good. Easy peasy, lemon squeezy types. Okay, next question. Can we solve this? Yesterday's class PDF will be sent just after this class. It was sent yesterday also, but you might have left the class. That's why you couldn't get. Okay, you will get just after the class. Don't worry. C option, D option, D option. Okay. So we will just rearrange it a little bit. It can be written as root 2 minus root 5 plus root 3, and this can be written as root 2 minus root 5 minus root 3. Now see, this became as a plus b and this became as a minus b, correct? Now we will take LCM, just take LCM. So this will be multiplied here. So root 2 minus root 5 minus root 3 plus root 2 minus root 5 plus root 3, and in denominator these two will get multiplied. So a square minus b square will be there, correct? A square minus b square. Now see what things are getting cancelled. Root 3 is getting cancelled. Okay. So we got 2 times root 2 minus root 5 here, and in denominator open it. So 2 plus 5 minus 2 root 10. Okay. Minus 3. So what we will get? 2 times root 2 minus root 5. This will become 7 minus 3, that is 4 minus 2 root 10. We can cancel a factor of 2 from numerator and denominator. So it will look like this: 2 minus root 10, not root 5 here, it will be root 10. Okay. Yeah. Now I can take root 2 common from the denominator. If I will take root 2 common, it will become root 2 minus root 5. Both of these things got cancelled. So we got 1 upon. Very good. Option D is the correct one. Just a solving here, nothing more. Okay. Can we move on to next one? Take a screenshot if you have not written this. Okay. No, option D is coming correct, no? See, we have taken 2 common here. If we will take 2 common here also, it will become root 2 minus root 5. If I take 2 common in denominator, we have taken 2 common from 4. So it will become 2 minus root 10. So these 2 and this 2 will get cancelled. Yes, we can do it by rationalizing the denominator, but we have to do 2 times of rationalization. Okay. Let's move on to next one. The product of two rational number is minus 40 by 3. Okay. Let's see this. Product of two rational number is, let the two rational numbers be. Let x and y be the rational numbers. Be the rational numbers. Okay. X and y be the rational numbers. Okay. So product of these two rational number is given. So x into y is equal to minus 40 by 3. X into y is equal to minus 40 by 3. If one of them is minus 5 by 2, okay, let y equal to minus 5 by 2. They are given, and the reciprocal of the another is x. Okay, so we can't take here x and y. Okay, so we will remove these things. Let's take a and b. Let's take A and B here. So product of these two is given as minus 40 by 3, and B is given as minus 5 by 3. Okay, 5 by 2. And the reciprocal of the another is x. So A equal to 1 by x, and reciprocal of another. So x equal to 1 by A, or A equal to 1 by x. Put both the values here. Put both the values here. So 1 by x into minus 5 by 2 will be equal to minus 40 by 3. Minus minus got cancelled. This is equal to 8. So that will be, I have done something, 6 by, okay, now this is also getting cancelled. Okay, so 5 8s are 40. So how much we will get? Okay, let's do this again properly. I think so you are having doubt here. Okay, see here. What they are saying is product of two numbers is what? Product of two numbers is minus 40 by 3. So A into B is equal to minus 40 by 3. And the reciprocal of the another is x. See here. Reciprocal of another. So 1 upon A is equal to x. Correct? 1 upon A equal to x. So x equal to 1 upon A. X equal to 1 upon A. Understood? Very good. So we can put x equal to 1 upon A is there. Both things are same. Now we will just interchange these two. Interchange these two. So A equal to 1 upon x. So I will put 1 upon x here. P value is minus 5 by 2. It equal to minus 40 by 3. Minus sign got cancel. Okay, we know 5 8s are 40. So 5 cancelled, 40 cancel, 8. So we got x equal to how much? See, x will go here, this will go here. So it will become 3 by 16. X equal to how much? 3 by 16. Correct? Now everybody understood this one? Now I will put x equal to 3 by 16 here, and I will get answer as 15 by 4. Yeah, the correct answer is 15 by 4, because we have to find the value of 8x plus 9 by 4. Harshita, very good. Ananya, understood? Okay. So can we move on to next one? Is this thing clear to everyone? Reciprocal of the another is x. Okay. Let's move on to next one. X is equal to 2 plus 3 root 2. Okay. So here we have to find the value of 1 upon x. So let's find 1 upon x first. So 1 upon, we can write it as 2 plus 3 root 2. We have just reciprocal it. Correct? Now we will just rationalize it. 2 minus 3 root 2 upon 2 minus 3 root 2. Because plus was here, so we will rationalize it by minus. Correct? So this will become 2 minus 3 root 2 upon a plus b into a minus b. That is a square minus b square. So this will become 2 square minus 3 root 2 whole square. So this will be 2 minus 3 root 2 upon 4 minus 9 into 2 is what? 18. Correct? So this will become 2 minus 3 root 2 upon minus 14. Okay. Now I will transfer the negative side to numerator. So 3 root 2 minus 2 upon 14 equal to 1 by x. Just cross multiply 14. So 14 by x is equal to 3 root 2 minus 2. We got the value of 14 by x. Now we require x plus 14 by x. So x plus 14 by x will be equal to x is 2 plus 3 root 2, and 14 by x we got as 3 root 2 minus 2. So 2 and 2 got cancelled. So we got the final answer as 6 root 2. That is option number A. We can directly substitute it, but let's make a habit to find the value of individual term individually. Okay. Okay. So see, one person is asking here that how we transfer the negative sign. This step, I am explaining this step. So can I write this step as 2 minus 3 root 2 upon 14? Yes or no? Minus sign can be taken outside. Okay. So when minus sign is multiplied inside, do we will get this step only? 3 root 2 minus 2, because minus minus will become plus and plus minus will be minus. Okay. Don't worry about the previous side, you will get the PDF. Okay. Just focus on the current question. Don't waste your time. These are just the practice question of yesterday's class. Tomorrow we will, whatever is completed up to now will be your syllabus for Saturday exam. Today is Wednesday, I think so. Okay. So whatever is completed up to Friday, it will be in the syllabus. We are sending, you are not attending class fully. At the end of the class, it was sent. Okay. Today also it will be sent. Yeah, online exam. Let's do this one. Try this one. Online test. Yeah. See students, we will discuss all the different topics at around end of the class. Let's now focus on the questions which we are doing. Okay. All other things I will discuss. Okay. Please have patience because the topic will get lagged. Okay. I will attend all the class, all the doubts at the end of 10 minutes of the class. Okay. Okay, let's do the question now. So it's given LHS is given as 3 plus 2 root 2 upon 3 minus root 2. So denominator is having a root, so we will rationalize it. Okay. So it will be 3 plus root 2 upon 3 plus root 2. Okay. So denominator will be a minus b into a plus b, that is a square minus b square. Now multiply these two. So 3 into 3 is 9. 3 into root 2 is 3 root 2. 2 root 2 into 3 is 6 root 2. And 2 root 2 into root 2 is 4. So we got 13 plus 9 root 2 upon 7. 13 plus 9 root 2 upon 7, which can be written as 13 by 7 plus 9 by 7 into root 2. So 13 by 7 and 9 by 7 are the answers. Okay. Easy question. Option A, very good. Naman, you are getting a wrong option. You have just interchanged that. Okay. Let's move on to next one. Take a screenshot if you have not written it. So let's do some exponent property. We all know what are known as exponent. Okay. So I will just here 4. See, 2 root 2 into root 2. This will become 2 times root 2 square, and root 2 square is 2. So answer will be 4. Okay. So let's write some exponent properties. We have studied in these in class 8. Okay, but we forget obviously. So see, first property is a to the power m into a to the power n is equal to a to the power m plus n. When bases are same, power gets added. Okay, when bases are same, then power gets added in multiplication. When bases are same in division, power get subtracted. Correct? A to the power minus n is equal to 1 upon a to the power n. A to the power n whole to the power m is equal to a to the power n into m. Do we all know these properties? I think so. We all know these properties. Correct? Okay. Any other property? If you remember about exponents, bases are same, multiplication, bases are same, division. Power is negative, so it will become reciprocal. Okay? Very good. Fifth one, anything to the power 0 is equal to 1, but a should not be equal to 0. 0 to the power 0 is not equal to 1. Okay? In root, okay, let's talk about roots also. Sixth property, if we write n here, n should belong to natural number. N should be 3, 4, 5 and so on. This means that a equal to 1 upon n. We can write 2 also, but we usually don't write 2 because we already know under root of a is equal to a to the power 1 by 2. We all know under root of a is equal to a to the power 1 by 2. Correct? Seventh property, a to the power n into b to the power n. This can be clubbed as ab to the power n. A to the power n into b to the power n can be clubbed as ab to the power n. Okay? N can't be negative because this is not in our definitions. Okay? This is a definition of exponents. Same thing with the division also. A by b to the power n can be written as a to the power n upon b to the power n. Okay. How a to the power 0 is equal to 1? For that, you have to visit your class 8 textbook. You will get the answer, Abhinav. It's a very basic thing. Okay. So just write this. I'm just giving a minute. No, Varun, that's a wrong property. A to the power m plus b to the power m. So this is a very wrong property. Okay, you can write this as property. This is wrong. This is wrong. We can't do it. A raised to the power 1 is A, obvious. And okay, let's move on to next part. Let's do this question first. As I explained again, I will take all the different doubts except the question doubts at the end of the class. 10 minutes I will give to that only. Okay, don't spam the messages with random doubts. We will discuss it. Don't worry. Your notes, your slide, your test, every doubt will be cleared. I am here for that only. Okay. So this question is given like this. Whole to the power 1 by 2 under root 248 plus under root 52 plus under root 144. Okay. So first we will start from the inside. What is root 144? What is root 144 here? So I will remove root 144. I can write 12. What is 52 plus 12? 64. Very good. And what is root of 64? Root of 64 will become as 8. Root of 64 will become as 8. Now, what is 248 plus 8? 256. And root of 256 is 16. And again 1 by 2, power 1 by 2, that is equal to 4. So, answer will be 4. So, we have to start from inside. Okay. Option D. Very good. So, easy question only. Can we move on to next one? Root 144 was 12. 12 plus 52 became 64. That is equal to 8. And this become 16. And 16 root is 4. So let's move on to next slide. Square root of any number is what? Square root of any number is always positive, always negative, always positive. Very good. Square root of any number is always positive. Okay, just tell me one thing. I am just giving you one more question here. X square equal to 4, then x equal to option A 2, option B minus 2, option C plus minus 2, option D all of these. Tell me. Option C, option A, option D. Okay. Think for a second. Option C. Okay. So if option C is correct, will option A and B also correct? If option C is correct, obviously option A and B will be also correct. Yes or no? So the correct answer will be what? Option D. Very good. So see, always remember this thing. If x square is equal to some quantity, let's say 9, answer after square root will be always plus minus. It will be always plus minus. Okay. Because if I will put minus 2 here also, minus 2 square will become 4, and obviously plus 2 square is also 4. Correct? So answer will be all of the above. All of these. But here they are asking a very simple question. They are asking what is under root of 4? Under root of 4 will be always plus 2. This will be always plus 2. You can't write it as minus 2, because if I will put x as minus 2 is equal to root, that is never possible, because root quantity is always positive. Understood? Okay, let's move on to next one. We have to see which is not true. Which is not true. This is A and B are given as positive number. So this is the property. This is correct. A square, okay. So I think so. We all got the answer. Okay, option number D. Option number D. This is the correct one. This is the correct one. We have to find a wrong one. So option D is the correct one. It will be A minus B. Okay. Okay. So let's start a new topic today. Okay, from which we have ended yesterday. all the formulas of algebraic identities we have done. Okay. Okay, I will just explain this once more, then we will go. Whenever x square is equal to something given, always take plus minus sign. Okay. So whenever x square equal to, let's say, 16, so x equal to how much? Plus minus 4. X square equal to 16, so x is equal to plus minus 4. Always a plus minus sign will come because minus sign will also satisfy this equation. Okay. For rest of the doubts, we will come again. Okay. Let's start with our properties which we done yesterday. Okay. So we have done the formulas. Okay. Again, I will just explain. What was AQ plus BQ? It was A plus B into A square minus AB plus B square. Okay. And we will just find another formula of AQ plus BQ. Okay. Another formula for AQ plus BQ. Okay. So we have done this formula. A plus B whole cube. This was equal to A cube plus B cube plus 3AB into A plus B. We have to find this value. So I will just put it here. Okay. Yeah, I will explain at last. Don't worry. Another question we will explain at last. Okay. So A cube plus B cube will be equal to A plus B whole cube minus 3AB into A plus B. Correct? Similarly, I will write A cube minus B cube. We have already done that. A minus B into A square plus AB plus B square. So what will be the another formula of A cube minus B cube? We will go to this formula. A minus B whole cube, that is equal to A cube minus B cube minus 3AB into A minus B. So I will bring it here and I will find the formula, that is A minus B whole cube plus 3AB into A minus B. Okay. Okay. Second one wrong, Avinash is saying. Very good, Avinash. A cube plus B cube is equal to what? A plus B whole cube. This will be transferred here. Okay. Understood? Now see, these formulas will be used as different places. This formula will be used when we are given sum of two numbers and product of two numbers. Okay. The second formula and fourth formula will be used when product and sum of the numbers are easy to find. I'm again telling, just write this thing. Second formula and fourth formula will be used when product and sum is easy to find. Understood? So you will say when it will be used, where it will be used. We will just do a question. Then you will understand it. First we will complete all the formulas all together. And your next question might be, sir, do we have to learn these formulas? Obviously, learn one, learn it. Okay. Third one, a cube minus b cube. We have already done this formula yesterday also. है ना? A minus b into a square plus ab plus b square. Okay. And second one is a plus b whole cube. Yeah, very good, very good. Okay, let's do the another formula. We know the formula of a plus b whole square, that is equal to a square plus b square plus 2ab. Yes, a plus b whole square everybody knows. So what will the formula of a square plus b square? I will just transfer this thing here. So it will become a plus b whole square minus 2ab. So a square plus b square equal to a plus b whole square minus 2ab. Okay. Now, where this will be used? You have used this thing in quadratic chapter also in class 10. Like sum of squares of roots alpha square plus beta square. Okay. Now, again, if I will write a minus b whole square, what this will be? A square plus b square minus 2ab. Okay. What will happen if I will subtract these two? What will happen if I will subtract these two? Subtract it. So this will become plus. So a plus b whole square minus a minus b whole square equal to 4ab. So I will bring this here. So a minus b whole square will be equal to a plus b whole square minus 4ab. So our sixth formula will be a minus b whole square equal to a plus b whole square minus 4ab. Okay. Understood? Any doubt in any of the six formulas? Second one. Now that's correct. That's correct. You are missing the point. I will just write the things here again. For the second and fourth one, I am thinking you are missing the point. Proof of second one. Let's say proof of second one we are writing. So it will be what? I have written a plus b whole cube, that is equal to a cube plus b cube plus 3ab into a plus b. I will bring this thing here. Okay. So a cube plus b cube will be equal to what? We are finding this value. It will be a plus b whole cube minus 3ab into a plus b. Understood? Sixth one, okay. We know what is a plus b whole square? A square plus b square plus 2ab. What is a minus b whole square? A square plus b square minus 2ab. So I have subtracted these two. See, I have subtracted these two. So this will become plus. Subtract. So a plus b whole square minus a minus b whole square. These two got cancelled. 2ab became 4ab. So a minus b whole square became as a plus b whole square minus 4ab. Okay. Okay. So let's move on to some good questions. Then you will understand where to use and what to use. Okay. So I will give you a random question only. X plus 1 upon x equal to 3 and find x square plus 1 by x square. Let's say if x plus 1 upon x equal to 3, find x square plus 1 by x square. Okay. So see, we let us take this as A and this as B. I am taking A as equal to x and B as equal to 1 by x. Okay. So what I will use the formula? I will use the formula of a square plus b square. That is equal to a plus b whole square minus 2ab. Am I correct? We have just done this formula a square plus b square. That is a plus b whole square minus 2ab. Now put the values here. It will be x square plus 1 by x square equal to x plus 1 by x whole square minus c. The product of these two will get cancelled. And we know the value of this thing. X plus 1 by x already given as 3. 3 square minus 2, which is equal to 7. Which is equal to 7. Okay. Again, let's practice more. Let's practice more. Then we will understand this. Let's find x cube plus 1 by x cube. Let's find x cube plus 1 by x cube. Okay. So What we will do here? Find the value of this thing. Yeah, squaring on both sides we can do, but we are learning the formulas here. Okay. So we will use A cube plus B cube formula. And which formula? In which sum and product are there? Okay. So we can write it as A plus B whole cube minus 3AB into A plus B. You don't have to Buttify it. Okay, buttification is the word here. Don't buttify it. In your mind, just do. What is A plus B whole cube? It's A cube plus B cube plus 3AB into A plus B. Shift this 3AB into A plus B to the LHS and you will get the answer. So just put the values here. Now I will just put the values here. So x cube plus 1 by x cube will be equal to x plus 1 upon x whole cube minus 3x into 1 by x into x plus 1 by x. This and this got cancelled. Now we already know x plus 1 by x is equal to 3. So this will become 3 cube minus 3 into 3, that is 27 minus 9, which is equal to 18. Very good. Most of you have written the correct answer, 18. I am impressed. Okay. Can we solve more questions? Can we solve more questions? Is it clear to everyone? Same concept, same concept. Let's practice more. Practice will make us perfect. Okay. So let's do this. If, let's make it 2, x plus 1 upon x equal to 5. X plus 1 upon x is equal to 5. Then find, I'm just giving you a practice question, x square plus 1 by x square and x cube plus 1 by x cube. Just same question, I have changed the value, nothing more. Just apply the formula fast. 23, 23, very good, very good. First answer is 23. Awesome. I will solve with you only. So I will use x square plus 1 by x square will be equal to x plus 1 by x whole square minus 2x into 1 by x. So that will be 5 square minus 2. That is equal to 23. Same question, only digits change. Now here also x cube plus 1 by x cube equal to x plus 1 by x whole cube minus 3 x into 1 by x into x plus 1 by x. This got cancelled. So we got 5 cube minus 15, that is 110. Okay, that is 110. We can use other formula also, but this is direct. Whenever one number is given and its reciprocal is given, okay, we can use it directly. Okay, so I think we are ready for an Olympiad level of question. Or Olympiad question in IOQM just came from this topic also. Okay, so it was an easy question. We can solve it. Okay, let's write. It came an Olympiad also. Let's write. If x plus 1 upon 16x equal to 3. Understanding? X plus 1 upon 16x, not only x. 16 times of x is given as 3. Find, find 16x cube plus 1 upon 256 x cube value. I will give you a minute. Solve it. So you will think, let I will give you a minute to try. Okay. Okay. So first thing, see here, this is not a perfect cube, nor this is a perfect cube. Both numbers are not a perfect cube, but we can make it a perfect cube. We can make it a perfect cube just by just by taking 16 common. Taking 16 common. So it will become x cube. And see, 256 is what? 16 square. So it will become 16 cube, x cube. So now this will be simply x cube plus 1 upon 16x whole cube. Now I think you can solve it. 423, 768, different answers we are getting right now. Okay, so let's apply the formula of a cube plus b cube. We all know what is a cube plus b cube. So it will be 16 times a plus b, a plus b, correct? Which is already given in the question. We are taking common, na? 16 is taken common. See, 16 taken common, so 1 by 16 will be multiplied here. Sharlene, are you understanding this? Okay. So a plus b whole cube minus 3ab into a plus b. Have I written it correctly? Okay, okay. So division. Say division is not a big thing. Let's say 16a plus b is written. Okay. If I will take 16 common, this will become a and this will become b by 16. Because again when I will multiply it, 16 and 16 will get cancelled and will again get b. Now I think so it's clear. Okay. So what is x plus 16 by x? That is equal to 3. So we will get 3 cube here. We will get 3 cube here. Okay. So it will be 3 cube. So it will be 3 cube minus 3. This and this got cancelled. This is 16 into again 3. So it will be 16 into 3 cube. I am just multiplying 16 again. Minus 16 into 9 by 16. So this and this got cancelled. So 16 into 27 minus 9. What is 16 into 27? 16 into 27. 423? No. 432. Very good. 16 into 27 is 432 minus 9. That is 423. 423 is the final answer. Okay. So it was direct based on the formula of a cube plus b cube. Which step you didn't understand? Just tell me. I will explain it again. First thing we have taken what? We have to find this value of this thing. So we have taken 16 common. When 16 is common, this will become 1 and this will become cube. 16 square was already there. Okay, Varun? Okay. Now this became a cube plus b cube. I have just applied the a cube plus b cube formula which we have done in the previous two questions also. So a plus b whole cube minus 3ab into a plus b. Right side is very easy. Anybody can do that. Okay. So here what I have taken in this 16 common. So I have shown it here also. If 16a plus b is there, I am taking 16 common. So b will be divided by 16. It was already 16 square. So one more 16 multiplied will make it as 16 cube. Now getting it? Hitesh, Vaishnavi. Okay. I think so. Now everybody understood. This was a very good question. Just give it a minute also. Solve it again. Okay. Let's do one more problem. Let's do one more problem. Okay. If x square plus 1 by x square is equal to 23. Find x plus 1 by x minus 1 by x, and you can find x to the power 4 plus 1 upon x to the power 4. Three things we have to find in this. Okay? Oh, x plus 1 upon x we are getting as 5. Let's solve it. So see here, a square plus b square. A square plus b square can be written as a plus b whole square minus 2ab. We have already done this thing. So x square plus 1 by x square will be equal to x plus 1 by x whole square minus 2x 1 by x. So x plus 1 by x square will be equal to x square plus 1 by x square plus 2. This is given as 23 plus 2. Okay. So x plus 1 by x whole square equal to 25. Everyone is saying plus 5, but what I have told you, whenever we are square rooting it, it will be plus minus sign, not only minus sign. Okay. So x plus 1 by x will be equal to plus minus 5. These kinds of mistakes will cost you a lot of ranks. Each number, like if you are writing a question wrong, it will deduct your 5 marks. 5 marks means around 5,000 rank gone. Okay. So we have to find x minus 1 by x. If you want, we can do it like this also. X, second method I am telling. If somebody is not liking this method, we can do it by this method. Square it. It will be equal to what? X square plus 1 by x square minus 2 times x into 1 by x. Okay, and what is given? 23 minus 2, that is equal to 21. And again, when I will square root it, it will become plus minus 21. We can do it by squaring both side also. Again, plus minus root 21. Sunkara, we have done that question in yesterday's class. 0 was the answer for that. Okay, you can visit in our YouTube channel. Okay, now we have to solve this. We have to solve this question. So what we will do? Okay, see here. We know x square plus 1 by x square is given as what? 23. What we will do? We will square both sides. We will do squaring both sides. So this will become x square plus 1 by x square whole square equal to 23 square. Some smart peoples are there. Some smart people, what they do, I will just show it here. When I will say square both sides, they will do x square whole square plus 1 by x square whole square equal to 23 square. And this is wrong. We have to make it a full bracket one square, not single digit squares can't be there. So it will become x to the power 4 plus 1 upon x to the power 4 plus 2x square into 1 by x square, and 150, sorry, 23 square is 529. 529. This got cancelled, 2 will be transferred here. So x to the power 4 plus 1 upon x to the power 4 equal to 527. Yes, you all got it right. Okay. So I will just give a homework question. Then I will discuss all your doubts all together. X plus 1 upon x equal to, let's say, 5. Find x to the power 5 plus 1 upon x to the power 5. Give it a try. Don't Google it. Don't Google it. Nobody can give answer in a minute. Okay. Avinash, you can do x to the power 6 plus 1 upon x to the power 6. He is stuck on that thing only. Do it. I know Avinash got one question right. Yeah. Now I will just discuss all your doubts. Okay. So let's go one by one. Yeah, ask, please. Yeah, test will be on Saturday. I will write everything. Test will be on Saturday. 3 p.m. timing will be there. Okay. It will be of 180 marks. It will be of 180 marks. Syllabus. Syllabus will be up to Friday portion. Whatever we will be completing up to Friday, it will be in the syllabus. Okay. I am just sending yesterday's PDF in the group. I have sent them. Okay. Yeah, I have sent yesterday's PDF there. It's in the chat. You can search it now. It was sent at 8:53 a.m. PDF at 8:53 a.m. timestamp. You can search in chat box. Yesterday, yesterday PDF. Okay. Yes. Okay. Let's go to previous one also. Okay. This is the previous question. Yeah. Today's class notes you will get at 9:05. Exactly at 9:05. Okay. Okay. Explanation everything. I will send one more PDF. Okay. You will get it. Don't worry. At 9:05 you will get. Remaining subjects also I will ask the EDP sir to send it. They will send it. Okay. Okay. So anybody was absent in the class, they can visit to Resonance channel. Resonance e-learning channel on YouTube. If anybody missed the class, they can go to this channel. You want any notes, you can go there. See it from YouTube channel. Okay. Exam will be online. Link will be shared. Okay. Everything go and see in this channel. You will get notes and everything. There is full video. No, if somebody has attended offline course, they do not need to attend exam, but exam is better only, you will improve. You have not got the PDF, go to this channel and see the notes, okay? If anybody want to see the notes, they can go to this channel and see it. For everyone, test will be there for everyone. Class is there, exam is from 3 p.m. I have written everything, every doubt is here. Yeah, marking scheme. I will just write the marking scheme also. 15 questions per subject plus 4 for correct, minus 1 for wrong, 0 for not attempting. 0 for not attempting. Understood? You will get the link in Saturday's class only. Don't worry for that. Negative marks I have written Varun here. You can see. Duration will be of 1.5 hour, 1 hour 30 minutes. No class on Sunday. Homework question I will discuss tomorrow. Very good, Karthik. You are a smart boy. You will do wonders in JE. At 9:05, I will send today's PDF also and previous PDF also. Don't worry. After ending the class, I will send all the PDFs again. Okay? Yeah, answer is correct. Okay? So, okay, tomorrow we will meet again, revise all the formulas of today and do it properly. Okay? I'm just sending the PDF again. Don't worry. I'm just sending it. Okay? Until then, any other doubts? Yeah, we will have matrix chapter also. Everything will be there. What tell? I couldn't get your question, Jitesh. Morning class is there, yeah. Sets will be there. For improving calculation, you can apply a trick. Whenever you see a bike number plate or car number plate, just add the digits. It will improve your calculation. Calculation starts from there only. Vaishnavi stuck on the minus 2 AB plus 2 AB. Okay. Okay, tomorrow we will meet. Okay. For anything, go to Resonance YouTube channel. Okay, e-learning one, and you can find every notes, everything there. Okay. My name is Suyash Chopra. I have uploaded today's class PDF also. Just go through it. Himayat Nagar. Okay. Chalo. Bye everyone.
Hello everyone, good morning, very good morning to all. Hope all you are doing good. Let's continue. Yesterday we were doing discussion on units and then later on we discussed about the fundamental quantities. The SI system gave us 7 fundamental quantities. So we discussed about them, discussed that on what criterias were they being declared as the fundamental quantities. And then there was a supplementary fundamental also. Now let's know that remaining all the quantities are called the derived quantities. Okay. So except those 7 fundamental and the two supplementary fundamental, if you talk about any other physical quantity, let us say whether it is a speed, acceleration, force, energy, resistance, potential difference, whatever names we have heard, all of these come in the category of the derived quantities. Why they are called derived? Because they depend on the fundamental quantities for their explanation or for their understanding or for their definition. Okay, so anyways, this was our discussion about the fundamental and derived quantities. Now today we are going to start with a new topic. We call it as the dimensional analysis. Okay, so let's begin. Dimensional analysis. Dimensional analysis, there are three, four different things what we do. The first thing is the dimensional formula. Okay, the overall dimensional analysis is a little vast thing. One part of it is what we call as the dimensional formula. So let's start discussing from here. dimensional formula. The dimensional formula of any physical quantity will be an expression which you might feel that is little bit similar to the units but little bit different. Okay, mostly we will not talk about the dimensional formulas of the basic quantities. See, we had those seven basic quantities, and to tell you that here in this discussion we will be mostly concerned with the first five of them. When I say first five, I mean mass, length, time, electric current, and temperature. Okay, I'm just not writing those remaining two terms, the luminous intensity and the moles. The reason is that we get our most of expressions in terms of these five quantities only. It's not like that the mole should not be considered here, but just to keep it to the point, I am straight away starting with these five of them. So what we do for the mass, we say the symbol will be capital M. For length, the symbol will be L. For time, the symbol is T. For current, let us say the symbol is A. And for temperature, let us say the symbol is K. So these are standard accepted symbols for these fundamental physical quantities. Okay. So if I ask you what is the dimensional formula of mass, your answer will be simply m. What is the dimensional formula of length? Your answer will be L. What's the dimensional formula for temperature? Your answer will be K. So basically, I'm only writing the symbol. You can mean that way. And that's why I said that you will be hardly asked about the dimensional formula of the basic quantities. Usually, we talk about the dimensional formula for the derived quantity. Let us first see how do I write the dimensional formula. Let me take up a few examples and then I will try to explain what do we mean by the dimensional formula and what does it represent. Okay, so straight away I am coming on to few examples. Suppose I want you to write the dimensional formula of speed, and I'm going to use the symbol V for the speed. So if I ask you to write the dimensional formula of the speed, now for this same question, we have a certain, I can say, a code representation or a symbol for that. I can straight away ask you like this. I can write a V and I will make this type of a square brackets. And if I simply put a question mark here, so this symbol has this shape of the bracket, it has to be interpreted as if I'm asking you the dimensional formula of the speed. Okay, so be clear. When I ask you what is this V bracket, this itself is the instruction to write the dimensional formula. Now, when you have to write the dimensional formula, what you have to do? You have to express every derived quantity in terms of one of the fundamental quantity. So here you will need the formulas for those quantities. If I'm asking you the dimensional formula of speed, then you must remember the formula for the speed. Now you may be remembering many formulas. You can say speed is equal to acceleration into time, speed is equal to momentum upon mass. I am looking for that formula through which I can express the velocity in terms of some fundamental quantity. So that's why I come up with the basic definition. I'll say velocity is defined as distance upon time. Now, if it is distance upon time, now see, distance is a fundamental quantity, time is also a fundamental quantity. So, when you are able to express the derived quantity in terms of the fundamental quantity, now what you are supposed to do, you are simply supposed to use these symbols. I told you here for the length we'll be using L, for the time we'll be using capital T. So I do this same thing here. Instead of D, now I write L. In place of time, I write T. So this L upon T is called as the dimensional formula of the speed. Okay. And now there is a common practice that usually we don't leave this expression in the form of a fraction. So what we do, we express it mostly like this, LT minus 1. We bring the term of time to the numerator, and I hope we remember this formula of indices and surds. X raised to m is equal to 1 upon x raised to minus m. So I have used that relation. So now it looks like MLT minus 1. And if you read in some books, you might read that the same thing is written as m raised to 0, L raised to 1, T raised to minus 1. As I told you yesterday, that earlier when the MKS system was introduced, at that time everybody thought that there are only three fundamental quantities, mass, length, and time. So that's why in those times every fundamental quantity would be containing only the terms of ML and T. So that's why it became a practice that whenever you are writing the dimensional formula, you have to write everything in the terms of M, L, and T. So you saw that actually in this expression there was no term of mass. Still, I wrote it like M raised to 0 here. And I think we all know that anything raised to 0 is equal to 1. So writing it like M raised to 0 doesn't make a difference. So the conclusion is that the dimensional formula of velocity is Lt minus 1, or I can say m0 Lt minus 1. It's one and the same. You can express it in either way. So one thing we have done for the speed. Now let's do a couple more. Let us write it for acceleration. So I am asking you to write the dimensional formula of acceleration. What you should do, the same thing, express the acceleration in terms of fundamental quantity. So start looking for the formula again. Acceleration can be defined as velocity upon time, right? And the velocity can be written as distance upon time. So I can express the acceleration as distance upon time upon time. That means it is distance upon t square. So now what to do? In place of d, write L. In place of t, write capital T. So the result appears like LT minus 2. Okay. So this is what I am doing right now is I am writing the dimensional formulas of the derived physical quantities. So what I am doing, I am expressing every derived quantity in terms of the fundamental quantity, and I am writing with what respective power do they appear in the result. See, the power of L is 1 and T is minus 2. In the formula for the speed, length was 1, t was minus 1. So you could see that the powers were different. Since the powers are different, therefore I will say the dimensional formulas are also different. So now let us talk about what do we mean by this dimensional formula. See, dimensional formula is the expression of a derived quantity in terms of the fundamental quantity with their respective powers. Power means this index, whatever we are calling. Yeah, I'm again repeating. Dimensional formula is the expression for a derived quantity. Let me write that. I'm writing DIM dot for dimensional. So, dimensional formula of a derived physical quantity refers to the power or index or exponent, whatever word you use. Dimensional formula of a derived physical quantity refers to the power or index by which a fundamental quantity has to be raised in order to express that derived quantity. So in general, for any physical quantity, let us say Q, if I say the dimensional formula is m raised to x, l raised to y, t raised to z. So these x, y, and z, I mean, they represent the dimensional formula. Our main emphasis is on these powers. For two physical quantities, if these powers are same, I will say the dimensional formula is the same. If the powers are different, I will say the dimensional formulas are different. Apurv, it's not a necessity that you always write m raised to 0. It is option. I just told you so that if you read it some other book or from any other source, you don't feel confused that maybe sometime we write m not and sometime we don't. Since it doesn't make a difference, so it becomes a matter of choice. Some people follow the old convention, some people have stopped it. Nothing bad, nothing good about that. We should just know that there are two types of expressions available. That's it. So, what is dimensional formula? In simple language, express every derived quantity in terms of MLT. See, now this is the proper definition. When we define, we have to be specific about the terms and the expressions we are using. But yes, for our understanding, we should be clear that when we are writing the dimensional formula of any physical quantity, you have to go in terms of the fundamental quantities, and that's what I have done. Uh, if the dimensional formula of any physical quantity, if the dimensional formula of any physical quantity is m0, l0, t0, if everything is zero in that, no mass, no length, no time, then such quantities are called dimensionless quantities. If dimensional formula of any physical quantity is m0, l0, t0, such quantities are called dimensionless quantities. All right. So it's not a necessity that every physical quantity must have dimensions. We do have few physical quantities which don't have any dimensional formula. And when I say there is no dimensional formula, I mean every power will be zero. I don't intend to say कि if there is no dimensional formula, you cannot express the derived quantity in terms of the fundamental one. You can always do that, but the powers of m, l, and t, all of them will be zero. Naman, the question what you have shared is having physical quantities which you haven't read so far. So my advice is please leave it. You don't know any of these four terms, how they are used. Until you know the formula, you can't write the dimensional formula. One student shared here a certain list of a question. Let me tell you, see, if you have to write the dimensional formula, you should first know the proper formula of that, right? If I had to write the dimensional formula of the speed, how could I write speed if I did not know that the speed is distance upon time? Got it? I must be having this knowledge that speed is distance upon time, acceleration is velocity upon time, then only I could proceed. If I don't know the formula, how can I expect that I'll write the dimensional formula? So, right now, I'll be giving those examples only which contains only those physical quantities which you have read so far. But once you understand the method, then later on, as any new physical quantity comes, you yourself will be able to do that. Okay, so right now, understand the process, the method, the logic of writing it. New physical quantities you will be able to do yourself once those quantities are introduced. Uh, at the ending of the class, can you tell the channel name of the resonance? Yeah, Sushant, that is resonance e-learning. And actually, just before the class, we'll take a halt so that the notes are also shared during the class only. I think some glitch happened yesterday. So today, just even before our class ends at 10:10, so just before that, we'll do that. And yes, I'll also write the name of the lecture here. So, well, we were talking about this dimensionless quantity. So let's take few examples of the dimensionless quantity. Number one, angle. If you remember, yesterday we defined the angle as arc upon radius, right? Now understand one thing. When we say the word length, it is length no matter with which name we call it. Why I am saying with which name? Because in different situations we give different names to the length, right? Sometimes we call a certain length as the radius of the circle. Sometimes we say one length as the altitude of a triangle. Sometimes we say a length is equal to the arc. So arc is also a length. If you are speaking about some wave, then wavelength will also be a length. So understand one thing, it doesn't matter that from which source the length is coming, which what type of length it is. We don't care for that. If it is length, we are going to call it L. Whether it's a radius, L, side, L, perpendicular, L. Whatever physical nature is expressed in terms of a distance, we will be taking it as a L. So now see, arc is itself a length, right? And radius is also a length. So if you divide L by L, do we get L raised to 0? Right? And you can see already there is no mass, no time, no other term. Only length was involved in the formula, and that is also 0. So whether you call it L0 or you call it M0, L0, T0, it's one and the same thing. And yes, you can say the angle is a dimensionless quantity. Okay? Abhinav, that's what I'm explaining. I'm saying angle is dimensionless because when I read the dimensional formula of it, the power of every physical fundamental quantity is coming as 0. Okay, that's why I am calling it is the dimensionless. Okay, now similarly, yes, one very good example, refractive index, Harshini. Very good, Harshini. Refractive index is another very good example, which is dimensionless. If I use the symbol mu for refractive index, it is defined as the speed of light in vacuum to the speed of light in medium. So see, actually C is also a speed and V is also a speed. It's only the difference that C is the speed in vacuum, V is the speed in medium, but fundamentally they are speed. So I can directly cancel this speed, and I say nothing is left. So I can say M0, L0, T0. So refractive index is a dimensionless quantity. One more example, all trigonometric ratios, all trigonometric ratios. I'm sure you must be remembering sine theta is perpendicular upon hypotenuse, cos theta is base upon hypotenuse, tan theta is perpendicular upon hypotenuse. Whatever result you are writing, whichever trigonometric ratio you write, doesn't it involves the division of one side by another side? Now that side can be either perpendicular upon hypotenuse, base upon hypotenuse, perpendicular upon base, and you know three more such pairs can be made, right? So in all these fractions, you can see that the numerator and the denominator are having the same physical quantity, distance upon distance. So all of them should be M0, L0, T0. So angle is dimensionless, refractive index is dimensionless, trigonometric ratios are dimensionless. Uh, Now, one more thing, but I'll give it to you as a question. Suppose I write an equation, but I don't tell you what the symbols represent. I mean, x raised to y is equal to z. If I say this equation represents some physical situation, it is correct. It is correct, but I don't tell you what is x, what is y, and what is z. So now I am asking you, can you tell me the dimensional formula of just one of these three? Out of x, y, and z, can you tell me the dimensional formula of just one of it? You can. Yes, the answer is you can. You can tell me the dimensional formula of one of these three. You can't give me two answers. You can only give me one. I want you to think without any information, only one information that this equation is mathematically correct. I haven't written something absurd on the equation. So, any guesses or any prediction? Which of these three dimension we can speak up? Okay, different answers are coming, and yes, few of them are correct also. Uh, the messages are scrolling at a very fast rate. I can't even read all of them. Anyways, let's discuss this. See, uh, whenever this type of equation is present in which there is a power or exponent, whatever you call it, shouldn't the power be always dimensionless? Shouldn't power be always dimensionless? Or let me ask you this way, you people might have written this thing 10-meter whole square. So 10-meter whole square is representing a square, the area of a square 10 meter by 10 meter. But tell me, have you ever read this thing 2 raised to 10 meter? Have you ever read this? Have you ever read 5 raised to 6 kg? Have you ever read 4 raised to 6 seconds? Did unit appear in any of the powers which we have seen so far? Remember, whatever expressions, whatever equations you have read so far, this thing would never have happened. The exponents can never have the unit. So yes, I can only say about y. Y has to be dimensionless if this equation is correct. Except it, I cannot tell about anything because I told you that x, y, z, they are all unknown. Okay? So, yeah, a few names we took here: angle, refractive index, trigonometric ratios, and now to it add the fourth name, power or the exponent. Okay, powers or exponents, they are always dimensionless. Now, other than this, try to understand one more thing. See, I'm sure you people have seen some expression like this: y equal to sine x, right? So what does it show? Y is equal to sine x. X must be some angle, right? You can define sine theta only when theta is an angle. You can't define, can you define this thing? Can you define sine of 10 kg? Does it make some sense? No. Angle will be defined as arc upon radius, and then only the sine theta makes some sense, perpendicular upon hypotenuse. How can you define sine of 10 kg? It is stupid. It doesn't exist. It doesn't make a sense if I write sine of 10 kg. So tell me one thing, if I write something inside the sine and I simply say that this is the correct equation. This is the correct equation. Now tell me, can I say the x is dimensionless? Right? So whatever you write inside this sign of something, I wrote sine x here only. Suppose if I write y is equal to sine of x plus z. Now again I don't tell you what is x, what is z, but I tell you the equation is correct. I take the guarantee that the equation is correct. Now you tell me what x is and what z is. I'll say x should be an angle, dimensionless. Z also should be an angle. Both of them have to be angle. Why? Because I know that as a whole, suppose after adding x plus z, suppose I get a v. So if I write this sine x plus z as a sine v, and I know that in the sine x, x is dimensionless, therefore I will say v is also dimensionless, right? If v is dimensionless, that means x plus z is dimensionless. I mean to say x plus z is dimensionless, but still the question remains x plus z is dimensionless. How am I so sure that x is dimensionless separately and z is dimensionless separately? How could I come on to that statement? Right? I had no reasons to say so. Now try to understand. There is one more aspect associated here. Tell me one thing. Do this equation look correct? 2 plus 3 equal to 5. Is this equation correct? Yes, correct. Now, let me modify it a little. Can I say 2 kg plus 3 meter is equal to 5 seconds? Now tell me, how does it look like? Absurd, of course, meaningless, or in simple words, wrong. Yes, correct. It's not correct. It's not correct. So, let's try to express what is the problem here. What's the problem here? Yes, correct. You're saying meaningless. And for the meaningless, we use one more word, inconsistent. Right? We use the word inconsistent. I can say this equation is inconsistent. Why? The first problem is that you can add only those two physical quantities which are having the same nature. You can add a force to a force, but you cannot add a force to energy. Am I right? You can add a speed to a speed. Can you add a mass to the speed? No. So, before I continue, I hope we all can agree on this point that the mathematical operations of addition and subtraction, they can be done only if they are identical quantities, or in other words, I can say they are similar. So now try to remember some results from our previous knowledge. For example, if I say the area of a trapezium, the area of a trapezium, we write it like this. See, if this is A, this is B, and if the height is H, we say the area is half sum of the parallel sides into distance between them. So now see, there is a sum involved of A plus B. Now tell me, could you add A and B if they were different physical quantities? If A was the length and if B was an area, could we be able to add A and B? No. So that's how, if the addition or subtraction is going on, and I say it is going correctly, it is enough to say that they must be having the same dimensions. Actually, I said they should be identical quantities, and if the quantities are identical, then certainly their uh, dimension formula will be also same. So now with all this, can I make a final comment that the addition and the subtraction can be done only on those physical quantities which are identical? I'm noting it down here. Addition, subtraction is possible with identical quantities only. Addition, subtraction is possible with the identical quantity only. And let me add one more statement. Dimension or dimensional formula does not change by addition or subtraction. That means whatever you get after addition or subtraction, still the physical quantity should have the same dimensional formula. Let's give an example. If I say 2 meter plus 3 meter, so isn't it necessary that the answer should also come in meter? Right. So see, I could add 2 meter with the 3 meter because both of them had the same dimensions, and I'm sure even after addition the dimensions don't change. Right. So keep in mind, even if I do 3 meter minus 3 meter, if I subtract 3 meter from 3 meter, I'll not say 0, I'll say 0 meter. Even the 0 will come with the unit. So it actually describes you that you are talking about the absence of a distance. Got it? You are talking about the absence of a distance. So where we were initially, yeah, here. In x raised to z, I said y is dimensionless, and here we defined the dimensionless quantities. The power exponents are dimensionless. Yeah, starting from here again. we were discussing that how could I be so sure that x and z are separately angles. X plus Z is angle, we are sure, but why is X and Z also equal to angle? Now I hope we can understand. Since addition is possible only between identical quantities, you could add X and Z only if they were identical, and that's why the dimension of X and Z is uh, what we can say same, it doesn't change. Fine. So see, I have given you these few names of those ideas which are, I mean, not the idea, sorry, those physical quantities which are dimensionless, these angle, trigonometric ratios, the argument of the trigonometric functions, the exponents. Now, there are some more items in the list which we are not discussing right now. There are some logarithmic functions, there are some exponential functions. They are also dimensionless, but so far we haven't studied all of them. We don't know exactly how the logarithms are carried on or how the exponential things are carried on. So those things I'm leaving for now. That will be taken later. When little idea of these things come in the maths, then after we will pick it up. So anyways, I hope the idea is clear to you. So let's continue with writing the dimensional formula of some more quantities. So let's get into the practice of writing the dimensional formulas. We have so far written only for the speed and the acceleration. So let's carry on, let's do it for a few more quantities. And I would like that if few people are having paper and pen right now, I'll write it, I'll wait for half a minute and I'll expect you people to write it meanwhile. Okay, one by one I'll be giving, and after taking a pause, I'll be solving them. So let's start. Number one, momentum. Symbol is P. So what should be the dimensional formula of the momentum? Uh, yes, Teju, I am speaking the principle of homogeneity. Correct, correct. Very well understood. So, see, momentum is defined as the product of mass and velocity. So, for the mass, let it be mass fundamental. For the velocity, you can write distance upon time. So, that's how this will become ml upon t, or you can write it mlt minus 1. All right, so that's the dimensional formula for momentum. Now let's write it for force. Try to write the dimension formula for the force. I can define force either as momentum upon time, or I can define the force as mass into acceleration. If you know two formulas or more than two formulas, you can use any of them. It's not like that one formula will give you the correct result, other might give you incorrect. It will never happen. No matter through which formula, if you approach the fundamental quantities, results will be same. See, if I write momentum upon time, momentum I already wrote there mlt minus 1 and divided by t. So that will make it mlt minus 2. Y minus 2, this t goes up and the power of this t will become minus 1. So minus 1 becomes minus 2. If I go through m into a, mass into acceleration, mass is m, and if you remember for the acceleration, we wrote lt minus 2. So that's how it will become mlt minus 2. So you can see I used momentum upon time and then I used mass into acceleration. The result didn't change. Fine. Next one. Uh, Work done. Gunayuk, it's not minus 1, it's minus 2. MLT minus 2, it's not minus 1. Work done is defined by the formula force into displacement into cos theta. Theta is the angle between force and the displacement. So now for all these three, we have already calculated the dimensional formula. For the force, we just wrote mlt minus 2. For displacement, you can simply write L, and this cos theta trigonometric ratio, this is dimensionless, so I am not writing anything there, just to show that this is dimensionless. So you can see you are having m as having one term, L into L, that will make it L square, so that becomes ml square t minus 2. So ml square t minus 2 is the dimensional formula of work done. Okay. Next one, kinetic energy. The formula for kinetic energy is half mv square. Now, when you write the dimensional formulas, you don't think about the numeral values involved. Whatever numbers are coming, you don't have to look at them. Simply look at the other physical quantities. Mass is m. Velocity we earlier wrote as Lt minus 1 and it has to be squared. So if I open the square, I get ml2t minus 2. Right? You can see that the dimensional formula of kinetic energy and the work done, they are same. And maybe you can correlate that there was a theorem called work energy theorem. The net work done on a body is equal to the change in kinetic energy. The work done is equal to change in kinetic energy. So if work can be equal to change in kinetic energy, can we say that in a way the work is being transformed into the energy? Right. So shouldn't they be equivalent? If mathematically, when you write W is equal to delta KE, I think it is in itself a sufficient proof to say that yes, they should be equivalent. And since they are equivalent, they are having the same dimensions, right? But be careful here. Uh, if the quantities are identical, they have the same dimensional formula. But if I simply say that the two quantities have same dimensional formula, you can't say the other thing that they must be identical. I mean to say that the statement is correct in one way, but the reverse is not true. Let me first write it and then give you an example. I am saying if two physical quantities have if two physical quantities have same dimensions, they may be or may not be identical, but if two quantities are identical, they have must have same dimensions. Okay. If two physical quantities have the same dimensions, they may or they may not be identical. But if two quantities are identical, then their dimensional formulas must be same. As far as the second statement is concerned, this one, if two quantities are identical, they must have same dimensions. This is the example of work done and energy. Since work and energy are equivalent, they are interconvertible. They can go from one form to the other. So you can see their dimensions are also same. But if I simply say you, uh, let's take the example of angle. What is the dimensional formula of angle? M0, L0, T0. What is the dimensional formula of refractive index? M0, L0, T0. So tell me, is the angle and the refractive index, are they having same dimensional formula or not? Yes, but still they are different physical quantities. You can't say angle is similar to the refractive index. Not at all. Angle is for something else and refractive index is for something else. In no way, in the widest possible interpretation, you can never say that, okay, angle and refractive index are identical. No, they only have the same dimensional formula and that's it. So, be very clear with these set of statements. If two physical quantities have same dimensions, they may be or may not be identical. But if two quantities are identical, they must have same dimensions. This I am writing DIM for dimensions. All right. Well, let's proceed again. We wrote it for the kinetic energy. And now let us do it for potential energy. And before even you begin to write it, shouldn't it have the same dimensional formula what the kinetic energy had? Can we say it from the conceptual reason also without the actual calculation? Can I directly say that whether it's the potential energy, whether it's the kinetic energy, thermal energy, sound energy, whatever source of energy you are having, shouldn't all the energies have the same dimensions? Yes. Yes, if it is energy, it has to have the same dimension. It doesn't matter in which form it is, from which source it has come, in what form it is manifesting itself. These all things become useless when you think about the dimensions of a physical quantity. So, well, for potential energy, we mostly use this result mgh. M is mass. Gravitation is similar to acceleration because small g is what we call as the acceleration due to gravity. Now, while writing the dimensions, you don't care due to what. For you, due to doesn't matter. For you, what matters is what it is. It is acceleration, right? So, if it is acceleration, the dimensional formula should be Lt minus 2. And lastly, h. H is a height which I can write in terms of L. So that's how the potential energy will be mL2 T minus 2. Got it? Yeah, notes would be shared, Abhinav. It's 10:1. In 4-5 minutes, the concerned person will come and he'll start doing that. Don't worry. Now, let's bring some physical quantities which involve charges or the current. So, let's first start with how to write the dimensional formula of electric charge. We use the symbol Q for this. Vani, G is taken as acceleration because when you say small g, this is actually called as a acceleration due to gravity. If you remember, its value is 9.8 meter per second square. So see, is acceleration, if you look at the units, you can still figure out that yes, it has to be acceleration, right? So due to what is immaterial? It's acceleration due to gravity or due to anything else, we don't care. It's acceleration, it has to be LT minus 2. All right? Yeah, now coming on to the charge. So the closest physical quantity to the charge in our list of fundamental quantities is the current. So I have to write the dimensional formula of charge. So I start thinking which formula relates charge with current. The simplest equation, current is defined as charge upon time, right? So see, current is fundamental, time is fundamental. I can write Q as equal to I into T. Current into time. Current is basic, time is basic. In place of current, I use the symbol A. In place of time, I use the symbol capital A. So the dimensional formula of charge is AT. Okay? A is for current and T is for time. Now tell me, do we remember how to define electric potential or even the potential difference? There is not much of difference, but do we remember the definition or the formula for this? Well, we have to write the dimensional formula of it, V, electric potential difference V. Now it is defined as work done per unit charge. This is how we define the electric potential work done per unit charge. Yes, from infinity to that point. The definition goes a little lengthy. Our formula part is work done upon charge. Now, for the work done, we already have written ml to t minus 2, and the charge I wrote previously as a into t. So tell me, if the t goes up, it becomes t minus 3. A goes up, it becomes a minus 1. And m, l, 2 are on their places as usual. So this ml2 t minus 3 a minus 1, this is the dimensional formula for electric potential. All right. So I hope you people are able to understand that what is the sequence, what is the pattern we are following here, how are we writing the dimensional formulas, right? Now, what is the benefit? What is the benefit of writing these dimensional formulas? So try to understand. Number one, when we use the word dimensions in our day-to-day language, we use the word dimensions either for the length, breadth, and the height, right? But in a different context, we use the word dimension in one more sense also. Yes, so now the notes will be uploaded. Whatever the board work has been done is done. Now I'll be explaining you the utility of this dimensional analysis. So yeah, I was telling you that when we talk about the dimensions, either we mean the length, breadth, and the height of something, but there is one more way in which we use the word dimensions, which actually explains the nature of dependence. Right? Suppose if I say, why is India a superstitious country? Why are people superstitious? You might have heard these debates going on that why do we have superstition? So maybe somebody says that because there is a lot of lack of education, just because of lack of education, there is superstition, right? Another person can argue and he can counter the statement. He can say that no, lack of education is not always the reason. We have seen many people who are highly educated into very big technical scientific positions and yet they are superstitious. So they will say there are more dimensions to this problem of superstition. So this is also the way in which we use the word dimension, that this problem has got many dimensions. Why is there is a poverty? Why there is a corruption? So when you answer them, there is no one single answer to it, right? There are dependence on so many different aspects. Very correct. So Abhinav, Arnav, sorry, this aspect is the right word. The dimensions of a physical quantity are telling you that a given derived quantity is dependent on the fundamental quantities in what manner. If you remember, before this charge, whatever we wrote, force, energy, acceleration, momentum, in none of them this term of current was there. A was not there. If A was not there, then you can conclude that all those physical quantities don't care about the current. If a force is exerted, then whether during the exertion of the force is current present or not present, it doesn't matter. If work is done at the time, if current is present or not present, it doesn't matter. Right? So, yeah, everybody, I think the notes have been shared. Can you see that, everybody? The physics notes PDF has been shared just now. Are you able to see that? Okay. Jaswant, I am still continuing. Let me go. So, uh, when we write the dimensions, we get to understand that how a derived physical quantity is dependent on the fundamental ones. And by having these numerical values precisely, ML2, T minus 3, now these numerical values will also help us a lot in many type of numericals. Now that application part we will be able to understand once we start our proper topics in the way. Okay, so far we haven't done any chapter. This is the first one. The applications will be able to understand once we start our regular topics, and then we will see how this idea of dimension help there. And trust me, it is a very easy but yet a very helpful idea. The knowledge about the dimensional formula, it helps you to shape your thought process. Okay, so that's all for today, right? So take care, see you again, bye bye.
So we are starting yesterday's beta class question discussion. Just slowly, I am revising what we discussed yesterday. So we discussed about all the fundamental particles, beta electron, proton, neutron, their charge, mass, and discover. And next, we discussed about isoterms, है ना? Isotopes, isobars, isoelectronic, okay, and isotones. So we are going to discuss now this revision quickly. Now first thing we discuss the isotopes. What is the meaning of isotopes? So isotopes, same atomic number, okay, same atomic number but different mass number. So there's a proton, same beta, for isobars same mass number, okay, same mass number but different atomic number. For isoelectronic, same number of electrons present. Okay, same number of electrons present. Then if we talk about isotones, है ना, same number of neutrons. अच्छा, how to calculate neutrons? Neutrons. So neutron calculation is A minus Z. Yes, A minus Z. Okay, and two terms remaining, so I will discuss today, beta. Okay, chalo. So one by one, we'll discuss the questions. First question is, which of the following is not a fundamental subatomic particle? Okay, which of the following is not a, okay, fundamental subatomic particle? So we know कि देखो electron is a subatomic particle बेटा. Okay, 1 minute. Electron is subatomic particle. Give me 1 minute. Just wait 1 minute. Okay. So answer for this is positron. Positron, can I say कि देखो electron, proton, neutron, they are subatomic particles. Positron is uh, not a fundamental particle beta. It is a anti or counterpart of the electron. Means positron has positive charge, है ना, and mass same as the electron. Okay. Next, charge of electron is, the charge on electron, A option, है ना, it is 1.6 into 10 power minus 19 coulomb. 1.6 into 10 power minus 19 coulomb is the charge. So what was the charge on proton? So proton and electron has same charge. Correct, correct, beta. Proton and electron has same charge. Magnitude wise, okay, but the sign is opposite, beta. Okay. Next, yes, relative mass of the electron. है ना? We discussed in the table relative mass of the electron. The relative mass of electron is, this point zero zero five for AMU. Okay, 0.0054 AMU. Okay, 0.0054 AMU. Okay, so A option is correct, beta. So which is the heaviest particle in atom? Which particle is the heaviest particle, beta? Neutron, yes. Neutron is slightly heavier than proton. Okay, but if we are counting the atomic masses or this, we'll take proton mass and neutron mass approximately equal for the calculations. But actually, neutron is slightly heavier than proton. Okay, next, isoelectronic pair among the following is, okay. Isoelectronic was isoelectronic. Isoelectronic means same number of electron, beta. अब calcium and potassium. If I check A option, calcium atomic number 20, potassium is 19. So they are not isoelectronic. है ना? अच्छा, for B option, argon we have and calcium 2 plus. What is the atomic number of argon? 18, calcium 20. So here beta 18 electrons present and this 20 minus 2 has also 18 electrons. 18 electrons. Okay. So we'll go for B option. Isoelectronic. Potassium and calcium 2 plus 19 and 18 not. Argon potassium 18 and 19. So our correct answer is B. Okay. Next, the triad of nuclei which is isotonic. Okay. Isotonic. Isotonic. Isotonic means the same neutrons. Acha, same neutrons. How to calculate neutrons? Neutrons are A minus Z. Neutrons A minus Z. So in the A option, if I talk about the A option, 16 minus 6, 8, 14 minus 7, okay, 7. So no need to check further. Here, if we check the B option, 16 minus 6, 8, okay, 14 minus 7, 7, okay, no need further. C option, 14 minus 6, 8, 15 minus 7, 8, okay, 8, and 17 minus is also 8. Which option better? So we'll go for C option. C is correct. Okay, next. The correct statement about proton. Okay, the correct statement about proton. Proton, it is a nucleus of deuterium. Okay, it is a nucleus of deuterium. अब discuss beta. Deuterium is 1d2 ना. Deuterium was 1d2. So we know कि it has one proton and one neutron. Deuterium has one proton, one neutron, and one electron also. If we remove, we have D plus, means nucleus. So nucleus of it is having one proton and one neutron. Okay, can I say A is wrong? Yes, agreed, no? A is wrong. Acha, it is an ionized hydrogen atom. Hydrogen atom. Beta, hydrogen atom means, can I say 1H1 protium? It has one electron and one proton, okay? And if I ionize it, what is? Only we have one proton. Yesterday also in the table I wrote ki H plus we can give the symbol. We can give the symbol H plus for a proton beta. B option. Acha, next. It is ionized hydrogen molecule. Hydrogen molecule. What is the meaning of hydrogen molecule beta? H2. H2 molecule. If I ionize hydrogen molecule, we have H2 plus. H2 plus. Okay. So H2 plus is not a proton. Here it is an ion. What is alpha particle? Alpha particle. But the alpha particle is helium nucleus. He2 plus. Okay. Alpha particle is a positively charged particle. No, alpha particle is a positively charged particle, not negatively charged. It's a positively charged particle. Okay, which has mass of alpha particle. Okay, is 4 times of mass of proton. Bit. Mass of alpha particle is the 4 times of mass of proton. Yes, correct, correct. Okay, next thing, its charge is 2 unit plus 2 charge. So charge of alpha particle is double of the proton charge. Okay, is it clear, Vito? This thing? What you are not getting? I am saying, Vita, helium particle. If we remove the 2 electrons, we get helium nucleus. Okay, helium nucleus is having, okay, positive charge plus 2 charge, okay, plus 2 charge, and mass, because it has 2 protons and 2 neutrons beta. So mass is the 4 time of the protons. Okay, so alpha particle is not a proton. Okay, alpha particle means helium nucleus or helium atom with 2 electrons removed. Okay, chalo. So can I go further? This is clear now, beta. What is the correct option for it? The correct answer is B option. It is ionized hydrogen atom. It is ionized hydrogen atom. Okay. Next, isotopes. Read the question carefully. Isotopes are atoms of different elements having same mass number. No, beta. Same mass number means iso bars. So it's not correct statement. Atoms of same element having same mass number. No. Acha, atoms of same element having different mass number. What is the meaning of same element? Same element means here Z is same, no beta. Z same. Z same or A different. Okay. So we'll go for C option. Atoms of same element having different mass number. Atoms of same element having different mass number. But here they are saying same mass number. देखो, what was the example? कि if I say 1H1 or 1H2, beta, protium and deuterium, are they isotopes? Yes, they are isotopes. They are isotopes. Then this is the mass number, na beta. Mass number is different, but atomic number same. Agreed? So C option, beta, correct? C. The number of electrons and neutrons of an element is 18 and 20 respectively. Its mass number is. The mass number A is equals to number of proton, okay, number of proton plus number of neutron now. Acha, neutron is given 20, है ना? But for an atom or an element, number of electrons and protons are equal. So can I use as an atomic number 18? Okay. So we'll get a resultant 38. 38 is the mass number, D option. Okay. Any doubt in this? Chalo. For next part, the nucleus of an atom contains, very simple problem beta, factual. The nucleus of an atom contains proton, electron, proton and neutron, proton, neutron, electron. Nucleus. देखो, if I write कि suppose this is a nucleus, है ना, and these are the outer shells. Outer shells. So in the outer shells, as you know, कि what is present? Electrons. Okay, and in the nucleus, protons and neutrons, which are known as nucleons. Okay, so protons and neutrons present in the nucleus of an atom. Simple. Next, the lightest particle. It's a good question, beta. Try to answer. Lightest particle. What is the lightest particle among this? Okay, and we will write the order also. Order also. The lightest particle is electron. Okay, even electron mass is 1 by 1800 times smaller than the proton mass. Okay, which is the heaviest particle here? Which is the heaviest particle here? So alpha particle has the mass 4 times. Okay, alpha particle has the mass 4 times of proton neutron. So alpha particle, then we'll go for neutron, then we'll go for proton, and electron mass is negligible as respect to others. Okay, if you remember the data now, this data was 9.1 into 10 power minus 31 kg, है ना? Where proton mass is 1.67 into 10 power minus 27 kg. Okay, so we'll go for lightest particle electron. Clear? Next, which of the following is isoelectronic with carbon atom? Carbon, है ना? What is the atomic number of carbon, beta? Atomic number of carbon. Atomic number of carbon is 6. है ना? Now we have to check isoelectronic. Isoelectronic means same number of electrons. So if I go for the first option, beta nitrogen plus, nitrogen atomic number is 7, so electron will come 6. Okay. As a oxygen O2 minus, oxygen atomic number is 8, electron will get beta 8 plus 2, 10. 10 electrons. Sodium, sodium atomic number 11, sodium plus, so we'll get 10 electrons. Okay. Next, aluminium. Aluminium 3 plus, atomic number of aluminium is 13, will get again 10 electrons. Okay. So which is isoelectronic for carbon is nitrogen beta, only A option. Achha, can I say कि this oxygen, sodium, aluminium, they are also isoelectronic to each other? Oxygen, sodium and aluminium, they are also isoelectronic to each other, but with 10 electrons. Okay. Next, compared to the mass of lightest nucleus. Okay, solve this question better. Just compared to the mass of the lightest nuclei, the mass of an electron is only approximately. Okay, so listen carefully. Key electron mass is 0.00054 AMU number. Electron mass in relative mass is 0.0054. Okay, and lightest nuclei means one proton. Agreed. Lightest nuclei means lightest nuclei means one proton only. If one proton present, one neutron present, I'll repeat, just wait for alpha particle beta. What I am explaining, listen. Okay. If you busy in writing your doubts in chat, you will not get what I am explaining. Please wait beta naman. Okay. So proton mass we discussed beta 1.00 है ना AMU approximately. If I take the ratio, if I take the ratio electron by proton, then this will get 1 by 1836 AMU. Approximately it is 1 by 1800. The given option is C here. Okay. So now I am taking you down. What is alpha particle you are doubting? It is helium atom. Helium atom. What is the atomic number of helium atom? Naman. Helium atom atomic number 2. Very good. And helium mass number is 4. Helium mass number is 4. Atomic number 2, mass number 4. Okay. What I am saying, okay, if we are counting 2 electrons, 2 protons and 2 neutrons, okay, or we are going to ionize helium atom, so what we'll get? We'll get helium 2 plus 2 electrons. Okay, helium 2 plus 2 electrons. Clear? I ionize the helium atom. Okay, so I got 2 electrons plus helium atom, this helium ion. Acha, helium atom is had 2 electrons, so there is 0 electrons but 2 protons present now. Can I say in helium 2 plus 2 protons present and 2 neutrons present? Okay, so अब देखो with the diagram, if I say nucleus and one shell, 2 electrons, 2 electrons. If I remove this, we have only nucleus, only nucleus. This is helium atom, this is helium nucleus. Helium atom, helium nucleus. Okay, in this helium nucleus, okay, only what is the charge present beta? 2 proton charge plus 2 and mass 4. Okay, this helium nucleus is known as alpha particle. Okay, in simple language we can say that alpha particle is nothing but the helium nucleus. Then you can remember the property. What we have to remember beta, what is the mass of alpha particle? It is 4 AMU, 4 times of the proton and neutron. Okay, and what is the charge on alpha particle? Correct, correct. What is the charge on alpha particle? Positive charge, but magnitude by 2 unit. Double of the proton charge. Okay? The charge is 2 unit plus 2. Great number. Okay? So now can I proceed better? Last step what? Last step this beta I am saying कि this is an atom. This is an atom. Okay. In ionization it loses 2 electrons. So what is present? Only nucleus is present. Okay. हाँ. Which of the following atoms does not have the same number of protons and neutrons? Same number of protons and neutrons, beta. So carbon 6 12, deuterium 1d2, tritium 1t3, nitrogen 7 and 14. These are the common atomic numbers and mass number of these elements. Okay, so the same number does not have the same number, does not have the same number. Tritium. Okay, everybody got the correct answer. Tritium is correct. Okay, next. An isotone N, same number of neutrons. Okay, same number of neutrons. So neutron number for the given 76 minus 32, 44. Okay, in which option we have the 44? By practice, slowly you can learn better small atoms mass number also. Okay. So what is the correct? देखो this one beta. Here we are getting 44. Easy. चलो next. Number of neutrons. Easiest question. Number of neutrons. है ना? So number of neutrons formula was A minus Z. Okay. So it is 32 minus 16. Answer 16 beta. Okay. 16. Correct. This is a question. It's a good question, beta. Try it. Try it. The table below PQRS. देखो, if I go with option, they are saying isotopes. For the isotopes, can I say we have to check here same atomic number, same number of protons? So देखो this 11 and 11 PQ. So can I say कि A is wrong and D is wrong? Got it? If beta 11 11, this only these two are having same atomic number, then we'll reject either B is correct or C is correct. Either B is correct or C is correct. Okay, now beta next they are saying isobars. Isobars. For isobars, the summation of neutron and proton should be same. Just wait Ananya, just wait. So if isobars, can I say for isobars देखो this option is PS and QR. If I check the PS, 11 plus 12 and 13 plus 14 wrong. Okay, but QR 12 plus 12 24 11, yes. C option. C option. Great. Great beta. Yeah, I know कि why there's a need to write again C. If you give the answer, yes, you are correct. Okay. हाँ. So C option. What was the doubt beta Ananya? Please repeat. Ananya, your doubt. I am coming now beta. I will in the last of this today's question discussion. I'll take isodiapers and isosters. Okay. Please wait. Next. Hmm. The number of protons, neutrons and electrons in this beta. देखो atomic number AC, atomic number 81 and mass number is 281. Atomic number. So protons, beta protons is 89 na? Neutrons 281 minus 89, okay, which is 192, and number of electrons is also 89. D option. Yes. An isotone of O oxygen 16. Isotones, same number of neutrons. Oxygen 6, sorry, not 6, it is 18. So 18 beta, 18. 8, 8 O 16, neutrons is 8. अब देखो this one 17 minus 8 not 12 minus 6, okay, 14 minus 6 is third option. C option. Okay. Next, the charge of the neutron charge, zero na beta. There is no charge on neutron. Okay. That's why it discovered very late in 1932 by nuclear reactions. 1H1, 1H2 and 1H3 are isotopes, isobars, isotones, isodiaphers. Simple problem bit. Okay. So 1H1, 1H2, 1H3, they are same atomic number, different mass number. We'll go for isotopes. Okay, isotopes. Okay. अब देखो two terms I want to discuss. Isosters. Isosters. What are the isosters, beta? We'll write like this: कि molecules. Okay. Molecules or ions. Ions also you can take. Okay. Molecules are of ions having same number of atoms, same number of atoms, okay, and same number of total electrons. Okay, same number of total electrons. These species are known as isosters. Now you can create easily the example better. Like if we have carbon dioxide, okay, and dinitrogen monoxide. Carbon dioxide and dinitrogen monoxide. Okay, please wait. Your comments are not coming. I am not able to visible. Okay, just wait. First, listen. Key molecules, ions having same number of atoms and same number of total electrons. Beta, same number of total electrons. Now, how to count the total electrons? So, carbon atomic number 6 and oxygen atomic number is 8. Okay. So here if I count the total electrons, it is 6 plus 8 into 2. 6 plus 8 into 2. Okay. 16 plus 6. Okay. So 16 plus 6 is 22 electrons. Up this is 7. 7 into 2, 14, and 14 plus 8 also 22. Okay. So they have same number of electrons and atoms. So CO2 is triatomic, dinitrogen monoxide is also triatomic. They have three atoms. They have three atoms. Okay. So they are isoesters. Next, if I take example beta, answer CH4 and NH4 plus. This. Okay. CH4 and NH4 plus. Try it. हाँ, CH4 and NH4 plus. The carbon atomic number is 6 na, or 6. Hydrogen is having 4. So electrons are present beta 10 in methane. Is it clear how I am calculating 10? Hydrogen atom 1 electron. 4 hydrogen atoms. Okay. Wait. I am telling again. Carbon atomic number 6. So 6 electrons. Hydrogen atomic number 1, but 4 hydrogen atoms. So 4. 6 plus 4. Total electrons 10. 10. nitrogen atomic number 7, atomic number 7, 7 plus 4, 11, but plus 1 charge means plus 1 charge, it loses 1 now beta. 11 minus 1, total electrons 10 here. Here, here now beta. This is 10 electrons. Okay. Okay. So next, if I discuss beta, ki we have suppose CO, carbon monoxide, comma NO plus or N2. हाँ. Yes. Ananya, I'm repeating. Just wait, है ना? CO, NO plus and N2 beta. CO, CO, NO plus and N2. Okay. Beta carbon atomic number is 6 और oxygen atomic number is 8. है ना? So electrons we are counting. Electrons. In carbon and oxygen, total electrons 6 plus 8 na beta. 14. Nitrogen atomic number 7, oxygen atomic number 8. So 7 plus 8, 7 plus 8, 15. Okay, very good beta who are getting the answer, very good. 15 minus 1, 14, minus 1. Okay, beta, ये Abhinav, is this our topic is going on yesterday's note? है ना? The topic is going on, focus on it, focus here. Okay, I'll stop 5 minutes earlier, you'll get the notes. This is also beta 40. Okay, so 14, 14, 14, 14, 14, 14, electrons same, or atoms also same beta, 2 atoms, 2 atoms, 2 atoms. So they are isosters. They are isosters. Okay, चलो अब tell me any doubt, Ananya, and who are doubt clear ना बेटा? हाँ, 1 electron lost, so 15 minus 1, 14, or N2 14. First example, okay, first example. देखो, carbon atomic number, बेटा carbon atomic number 6, carbon atomic number 6, okay, and oxygen atomic number is 8. Okay, now clear? Now 8 plus, देखो this 6 plus 8 into 2. Why 8 into 2? Because this is uh, 2 atoms with oxygen, 2 atoms are there. So 6 plus 16, 22. So we have 22 electrons here. Okay. Or N2O is 7 into 2 plus 8, 22. Okay. Examples clear na? Definition is क्या बेटा? Molecules or ions which having same number of atoms also, or they are isoelectronic, same number of electrons. Okay, चलो. Isodiaphers. Okay, isodiaphers. What is the meaning of isodiaphers? Okay, so isodiaphers is with a atoms or nuclei. Okay, atoms or nuclei of same, sorry, not same, different elements, different elements having a minus 2z value same. Okay, having a minus 2z value same, they are known as, beta isodiaphers. अब only one example I will take so you can easily answer beta. देखो, if we have carbon 6 or isotope is 13, okay, and nitrogen 7, isotope is 15. ओके चलो अब a minus a is what beta? A is 13 minus 6 into 2. Okay, so here we'll get 13 minus 12 1. So here in both beta case a minus 2z is coming 1. So they are isodiaphers. Isodiaphers we required in beta nuclear chemistry or nuclear physics, which will come in second year. Okay, so writer it's no use, but in for your information I took this key what are isodiaphers. Okay, chalo now we can start our topic beta. हाँ okay, अब please stop chatting, stop writing in the chat box, please listen what I am saying. Okay, because from here the topic is very important, or these are the results or information based off the higher level experiments beta, है ना? So first I have to discuss. Yes beta I'll send, please wait, है ना? I will stop class, है ना, 2-3 minutes earlier, then technical team will share you the PDF. Okay, please be patient beta. Okay, so what I am saying beta, what is the journey of the journey of this atom and its structure discovery, है ना? तो initially you know na Thomson model. Thomson, J.J. Thomson gave one model which is known as plum pudding model, and also known as beta watermelon model. If Indian context I'll say, then I can say na ki it is in plum pudding model, in which can I say ki atom is a positively charged sphere. हलवा मॉडल नो बेटा इट्स प्लम पुडिंग, अंग्रेजों का हलवा कह सकते हो आप. ओके, so it is in plum pudding model or watermelon model, in which like watermelon is having red part na, red red part, हाँ correct. Okay, red part of the watermelon is the positively charged sphere, and in which sheets are embedded. Okay, so Thomson explained कि electrons are embedded in it. Electrons are embedded in it. Okay, but his student Rutherford tried. Okay, student Rutherford tried beta what? Rutherford tried कि bombardment of alpha particles in thin sheet gold foil experiment beta. So then he proposed कि no, atom is emptied. Total atom is empty. In the center, nucleus is present. So this experiment leads to discovery of the nucleus, you know, and he gave his model in the basis of planetary model beta. Then Bohr's model, हाँ nucleus discovery, correct. Then Bohr's model. Then beta Bohr's model is not consistent with two theories which are like de Broglie hypothesis and Heisenberg uncertainty principle. We will study this thing in a sequence in detailed manner beta. What we are going to learn, is the wave mechanical model of atom. Okay, or here the result we have to study ki what is orbit, what is orbital. Okay, and on the basis we can try to learn है ना कि how to locate the electron, okay. Yes beta PDF will share. Chalo, so this is what atomic orbitals will starting. Okay, atomic orbitals. Beta according to Bohr है ना, Bohr orbit, what is the meaning of Bohr orbit or shell? This you studied in lower classes. Bohr orbit or shell. Because according to Bohr, positively charged dense object is a nucleus, or here infinite energy orbits are present beta. Circular 2D path are present. Infinite. These are known as orbits or shells. Means infinite energy level where electron is revolving in two-dimension motion. Okay, so n equals to 1, n equals to 2, n equals to 3, n equals to 4. These are the cell number. Orbit number or shell number. Acha, what is the name of first shell? है ना? This K shell, L shell, M shell, N shell. Okay, K, L, M, and capital. We'll use the capital letters K shell, L shell, M shell, N shell, Bohr or orbit. So these are the fixed energy orbits in which electron present. Beta. Fixed energy orbits means electron neither lose energy nor gain energy if it is revolving around the nucleus. So can I say orbit is representing a 2D motion? Two-dimension motion around the nucleus. Okay, अच्छा हाँ, total number of electrons. So I am going to it. देखो, अब बेटा orbit concept was given by है ना Bohr, but the way mechanical model says कि electron is having dual nature. Electron is having dual nature means it has wave nature or it has a particle nature. Okay. What is the meaning of particle nature? Ki around the nucleus, suppose electron is revolving. So this is the path of the electron, fixed path. Okay. But according to wave nature, we will say ki electron is moving around the nucleus. Then, okay. Then this is the wave nature it is showing, beta. Wave nature of electron. Okay, so what is the meaning of orbit? You think like this, beta. You suppose I have a spherical, है ना, spherical cage. In this spherical cage, a honey bee is present. I'm repeating. In a spherical cage, a honey bee is present. Up this honey bee will go, है ना, round and rounds around, zigzag motion, move everywhere. So what I will say, कि where is the honey bee present? I will say it is present inside that spherical cage, and the probability of finding is of honey bees highest in that cage only. Clear? Okay, so if we are going to check the position of electron, we can't say. So what is orbital? A three-dimension region in space around the nucleus where the probability of finding electron is maximum. Where the probability of finding electron is maximum, okay, it is known as orbital. Or if probability is more than 90%, we will say that this region is the beta orbital. So orbit, you can take a screenshot, just wait beta. Orbit means a two-dimension circular motion. Orbital, I am saying ki a region in space, a three-dimension region in space where the probability of finding of electron is maximum. Okay na? Ki if I say ki I am present in Chola campus beta at the 6th floor and this recording room. So what ki I am present where in this room is fixed. The probability of finding this time is maximum in this room. Okay? I am going. लो take the screenshot beta. तुमको more than the explanation, you require the screenshots. Beta, these are everything is present in books. है ना? This is the first page. This is the second page. Take the screenshot of it. So orbital meaning is clear. Yes, in this beta you have two exams. In this B2B program, you have two exams. Yes. So orbital meaning is clear na beta? Orbital meaning. Orbital is a three-dimension region in space where the probability of finding electron is maximum. But orbit is a well-defined path. Ki electron can be present. Okay, electron can be present in this orbit only. But a wave nature and particle nature now we have to discuss all the Planck quantum theory, everything. But just remember कि as light is considered as a dual nature na. Small particles like microscopic particles, electrons also, they are also said to be having dual nature. Okay. For the dual nature, I have to explain de Broglie hypothesis. Okay. Or I have to explain Heisenberg uncertainty principle, then Schrodinger wave equation. So please, right now, most of thing we will take care as a information beta. Okay, chalo. So it represent both particle and wave nature of electron. Probability of finding electron is more than 90%. अब these orbitals are beta said to be like s orbital, p orbital, d orbital and f orbital, है ना? s, p, d, f, they are the names of the orbitals. So p, d, f orbitals are directional in nature and s orbital is spherically symmetrical beta. S orbital is spherically symmetrical. Okay, orbit is the path or orbital where the maximum probability we are finding of the electron. Maximum probability, more than 90%. Correct, beta. Okay, so if beta we have same value of n means shell or orbit, and subshell, then these orbitals are known as degenerate. What is the meaning of degenerate orbitals? Degenerate orbitals means they have equal energy. Degenerate orbitals are having equal energy. So देखो this diagram, what is the meaning of this diagram beta? This part is nucleus, this part is nucleus and more density present here in a spherical manner beta. Okay, so high density means high probability of electron. Now here we are taking electron as a electron cloud or the electron density. Next. Okay. So now I am going to discuss better. Like suppose we have shell. Beta shell is represented by n. N. Which type of shell we have? K shell, L shell, M shell, N shell. In the shell na, there are some subshells. Subshells. Subshells are the sub energy levels. Sub energy levels. In the subshells, orbitals are present. This is the hierarchy, orbitals. Or in the orbitals, electrons are present. Okay? Shell, inside subshell, in the subshell orbitals, electrons. You can learn that there is a building. Okay? In the building, we have different floors. Okay, in the different floors we have different rooms, different room number. So shell, subshell, orbitals and electron, which shows the address of electron inside the atom bit. It is address of electron inside the atom. Yes, I'll discuss the quantum numbers, just wait, है ना? Yes, what is the doubt bit, Apurv? F orbital is complex. Orbit present in the orbital, sir? No. Orbital present in the orbit beta. देखो this. If we discuss the difference na orbit and orbital, okay, we can answer easily. The difference between orbit and orbital. Acha, if I say spherical, it means directional. Spherical. Spherical is present in all directions. But if I say ki it is present along the axis, x axis, y axis, z axis, then what is the meaning with it? If I say if it is present along the x axis, y axis, z axis, then it is directional. So directional and non-directional means कि if electron density or electron probability of finding of electron is along any direction, then it is directional in nature. Or if it is present in all the direction better than non-directional, like orbit, a circular path. Orbit, a circular path. A circular path we can say is non-directional. Okay, orbital, if it is spherical, then non-directional. Okay, d or orbital is double. Yes, correct. So देखो, orbit is a well-defined circular path of revolving electron. Okay, it's a well-defined circular path of revolving electron. So orbits are like K, L, M, N, O, P, like this beta. Okay, orbital is the 3D region of space where electron is most likely found. Next, it represents the planar motion, means two-dimension motion, beta, 2D motion, planar motion of the electron. It represents the planar motion of the electron, but represent the 3D because orbital is the space in 3 dimension where we are finding the electron. Okay, so it is the 3D motion of electron. Maximum electrons 2n square beta. So if I say we have K shell, M shell, M shell, N shell. Beta, K shell means n equals to 1, L shell n equals to 2, M shell n equals to 3, or N shell n equals to 4. Okay na? Maximum electrons, maximum electrons. How many maximum electrons possible for K shell? So 2n square, n is 1, 2. Then maximum electrons in L shell beta 8, M shell 2n square 18, N shell 32. Okay. So in this, with this formula you can calculate. Acha, what is the shape? So it is circular, है ना? Circular. Acha, can I say orbits non-directional? No? So it cannot explain molecular shape because if molecular shape, molecules have the geometry, the shape, the direction, or orbits are non-directional, then concept of orbit is not capable to explain. Okay. Next, maximum electrons 2 per orbital. Okay, maximum electrons 2 per orbital. So orbital we will represent like a box, है ना? If box diagram, 2 electrons, then how many electrons can be filled beta in an orbital? 2. How many electrons in an orbit? 2 and square. But how many electrons, maximum electrons in orbital is always 2, which is explained by Pauli's principle. We'll discuss better. Pauli's principle. Next is different shape. S is spherical, P is dumbbell shape, D is double dumbbell, double dumbbell, F is complex or clove leaf structure beta. Directional. So all are directional except S. Okay. So if you want to take the screenshot, please. And for this also you can check the animation. है ना? Animation. Okay, so देखो directional shape और we'll discuss in the next class बेटा ना. चलो you required notes ना बेटा. I'm asking to share the notes. Okay, check this PDF. Just wait.
Good. Fine. Now there are three types of formed elements. What are the three types of formed elements? Erythrocytes, leukocytes and thrombocytes. Right? What are erythrocytes? Yesterday we completed about erythrocytes. What are erythrocytes? Nothing but red blood cells. Why are we calling it red blood corpuscles but not red blood cells? Because they are not having cell organelles, because they are not having cell organelles. Coming to the shape of human RBC, the human RBC is biconcave in shape. It is biconcave in shape, right? And then we move to the next. Where it is produced? It is produced in the bone marrow by the process of erythropoiesis. How is this erythropoiesis occurring? Our kidney releases a hormone called as erythropoietin, which stimulates the bone marrow to produce RBCs. This process of production of RBCs by the activity of the hormone erythropoietin released by the kidney is called as erythropoiesis. It is what is called as erythropoiesis. Formation done. What is its lifespan? Coming to the lifespan of RBC, it is 120 days. It is 120 days. Next, lifespan is over. It has to die. Where does it die? It dies in the spleen. That is the reason why spleen is called as the graveyard of RBC. Coming to the count of RBC, talking about the count of RBC, RBCs, their average value is 5 to 5.5 million per cubic millimeter. Per cubic millimeter. In male, it is 4.5 to 5.5 per million per cubic millimeter, and in case of female, it is 3.5 to 4.5 million per cubic millimeter. Female is having less number of RBCs because of the monthly cycles, that is the menstrual cycle. Okay, now this RBC is having a red colored iron containing pigment which is called as hemoglobin, What is the function of hemoglobin? Hemoglobin is responsible for the transportation of respiratory gases like oxygen and carbon dioxide, Okay, now this hemoglobin on an average, it is 12 to 16 milligrams per 100 ml. In case of male, it is usually 14 to 16 milligrams per 100 ml, and in case of female, it is 11 to 12 milligrams per 100 ml. Again, a female is having less number of RBCs because of again the same reason, that is menstrual cycle or the monthly cycles. Is it clear? So we have completely revised the topic till where we have actually learned till yesterday's class. I hope the revision of the topic is done. Is it okay? Spleen definition, Anna. Spleen is nothing but a lymphoid organ. Okay. It is having a secondary effect. That secondary effect is production of lymphocytes, which you can keep it aside for now. Rather than that, spleen is a part which is present in the mid region of the thoracic cavity near the liver, which is actually responsible for the denaturation of RBCs. RBCs are destroyed in the spleen. If the RBC's capacity is going, RBC has become old, it has to die. Where does it die? From entire body, it will be reaching again to the spleen and it will die. Is it clear? Yes, Bhagyashri. What happened? What happened? What's your doubt? Nana, are you understanding bio class? Are you understanding bio class? Yes? Is it interesting? Okay, fine. Then I'm happy. You people are happy, that makes me also happy. Fine. Okay, so till yesterday, we learnt about the formed element erythrocyte. What are the remaining two formed elements? The remaining two formed elements are nothing but leukocytes. Okay, I'm not writing that again. I'm directly starting. Okay, I will be continuing. Okay. Formed elements, leukocytes and thrombocytes. Yes. Actually, before I move to leukocytes and thrombocytes, I would like to tell you one thing. Like, I would like to answer one of your questions. I don't know who, I don't remember the name actually, but one of you asked that, ma'am, our RBC is biconcave in shape. But when we are talking about the camel's RBC, why is the camel's RBC biconvex in shape? Why is the camel's? Can anybody, who asked the question? Can that person raise the hand? He's there, he's not there, he or she is there, not there. However, I will answer this question because we have completed RBC. I would like to answer that question as well. Camels, where do they live? They live in deserts, right? Now, a camel, because it is living in desert where there is a lack of water, where there is lack of water. So when it gets water, then only it will consume a lot of water. Matlab, a camel can consume 100 liters of water. Now it is consuming 100 liters of water and storing it inside the body. If the shape of the RBC is biconcave, then what will happen? This water, more intake of water, this water will enter into the RBC and the RBC will burst and the RBC will burst. But rather, because the camel is having biconvex shape of RBC, this biconvex shape of RBC can retain water. Even though the consumption of water is more, though it will not burst. This is one of the reason. Understood? This is one of the reason. Second reason is now it is living in desert areas, right? It is living in desert. Now when it is living in desert, obviously more and more dehydration will be there. है ना? When more and more dehydration is occurring, matlab water from the blood is lost. When the water from the blood is lost, obviously blood will become thick. Blood will become thick. Now, if there are, again I'll tell you both the if there are biconcave shape of RBCs, biconcave RBCs cannot move in the blood capillaries in thick blood. Okay, if inside the blood capillaries the blood becomes very thick, then biconcave RBCs cannot move through it. Rather, if it is a biconvex shape of RBC, even if the blood becomes thick because of the dehydration, biconvex RBCs can easily move through the thick blood also in the blood capillaries. That is the reason why, though this is a mammal, the shape, though the camel is a mammal, shape of the RBC is biconvex, which is a special adaptation for its habitat, that is desert areas where the quantity of water is very less. Is this clear? Did you understand this? Yes. Okay, now moving on to the remaining formed elements, that is leukocytes and thrombocytes. Okay, so first let us see about leukocytes. So what do we know? What are leukocytes? WBCs, which means white blood corpuscles. White blood corpuscles. Okay, when we were talking about RBC, okay, RBC was not having any nucleus. But when we are talking about WBC, remember WBC is having nucleus. WBC is having nucleus. Okay, there are different shapes of the nucleus that we'll be learning in the later part. First, I would tell you about the count and lifespan. When we are talking about the count of WBC, the count is 6,000 to 8,000 per cubic millimeter, okay, which is comparatively less when compared to the erythrocytes. So the count of RBC is 6,000 to 8,000 per cubic millimeter. In general, we know one thing, white blood corpuscles are nothing but the soldiers of our body. Whenever a foreign particle is entering into our body, these policemen of our body will get ready and fight against the disease causing microorganisms or the foreign particles, right? So that is the basic function. That is the basic function. Count comes to be 6,000 to 8,000 per cubic millimeter, and talking about the lifespan. Talking about the lifespan, it is 6 to 7 days, very short lived. RBC lifespan was 120 days, but WBC lifespan is only 6 to 7 days. Okay, now for seeing blood, okay, When it is put on a when it is observed on a microscope, it is put on a slide, microscopic slide, okay, it is stained. We need to observe different components of blood, right? So it is stained. This WBCs, or you can say the leukocytes, is also stained. It is also stained based on the cytoplasm. Based on the cytoplasm, if the cytoplasm has granules, okay, granules means dot dot structures in the cytoplasm. If the cytoplasm has granules, it is called as granulocytes. If the cytoplasm is clear, it does not have any powdery substance, then it is called as agranulocytes. Okay, so these leukocytes, based on the presence or absence of, I'll write based on, when I write it over this, then it is called as on the basis of, or based on what the classification is done. Based on granules, okay, I'll write it over here. Based on granules of cytoplasm. Based on granules of cytoplasm, it can be further classified into granulocytes, granulocytes and agranulocytes. It can be further classified into granulocytes and agranulocytes. So in case of granulocytes, it will be having granular cytoplasm. It will be having granular cytoplasm. In agranulocytes, it is having clear cytoplasm. It is having clear cytoplasm. Okay. Next, these granulocytes can be further classified into, will you give me time to explain? Yes, Samudva. Shall I? You have very good points, which are also there in my brain that I am supposed to teach, because once I complete this, then only I will be telling you those points. No, before knowing the classification, I cannot tell you these points. Okay, Samudva, I appreciate that you have a great knowledge. Who is this danger smiley who has raised hand? Shall I continue? Yes. Yes or no? Yes or no? Okay. So, leukocytes on the basis of granules of cytoplasm can be divided into granulocytes and agranulocytes. Granulocytes means they are having granular cytoplasm. Agranulocytes means they are having clear cytoplasm. Okay. Now, these granulocytes can be further classified into three categories. Can be further classified into three categories. What are they? Neutrophils, neutrophils, eosinophils, eosinophils and basophils, and basophils. Okay, coming to the quantity of each one of them, neutrophils is 60 to 65 percentage, eosinophils is 2 to 3 percentage, basophils is least 0.5 to 1 percentage, 0.5 to 1 percentage. Okay, got it? Okay, now we should also be learning, why not should we white blood cell that had nucleus, right? White blood corp. Are see, it's not only about the nucleus, it is about cell organelles. Samiksha, I am answering your question. It's not only about nucleus, okay? It is actually about all the cell organelles. Understood? That is the reason why we name it as white blood corpuscles. Remaining organelles are absent. Got it? Now these granulocytes are of three types: neutrophils, eosinophils and basophils. Okay, now see about them. Neutrophils, how does it look like? Neutrophils, Nana, are you able to see red color? I think I should be using some light color only so that it's good. Yes. Can you see the cell over here? So the cell is having, wait, the cell is like this. This is a neutrophil. This neutrophil has multi-lobed nucleus. Multi-lobed nucleus. And obviously because it is a granulocyte, the cytoplasm is having certain granules. Certain granules. So neutrophils ke bare mein if you learn the points, then it is multi-lobed. I'm using multiple colors only to make the clear difference actually. It is having multi-lobed nucleus. It is having multi-lobed nucleus. And the function of neutrophils, this is very important, we should be knowing the function. The function of neutrophils is phagocytosis. What is it? It is phagocytosis. What is phagocytosis? A foreign particle is entering into your body. This neutrophil will identify the foreign particle. It will go engulf the foreign particle and destroy it. Like amoeba. How does amoeba eat its food? It will form a pseudopodia. It will be forming this, it will be extending its pseudopodia around the food particle, take it into the cytoplasm and destroy it. Same is in the same way, neutrophil causes phagocytosis. What does it cause? Phagocytosis. Moving to the next one, that is eosinophils. Eosinophils is having a bilobed nucleus. Bilobed nucleus means two lobes are there, and obviously the cytoplasm is granular. Okay, now knowing about its function, first one, bilobed nucleus. Okay, it is responsible for allergic reactions. It is responsible for allergic reaction. Have any one of you heard the term anywhere about eosinophilia? Have you heard eosinophilia? Yes or no? Eosinophilia is nothing but the condition in which number of eosinophils increase in the blood. Okay, in that particular case, nose starts bleeding. The person is not prone to, or the person is very allergic to the low temperatures, not high temperature, low temperature. Even if they sit in AC, very cold temperature, no, their nose starts bleeding. In winters, if they are prone to this cold temperature, their nose starts bleeding. This is the condition called as eosinophilia. And this eosinophilia is nothing but because of the increase in number of eosinophils. Okay, so what is the function of eosinophil? Eosinophil is responsible for allergic reaction. Arnav, you are asking me about the functions of neutrophils and eosinophil. Neutrophils, phagocytosis, which means killing up the foreign particles. It will engulf the foreign particle, destroy it. That is the function of neutrophil. Eosinophil function is allergic reaction. If eosinophil, there is a particular count. How much count? 2 to 3% of blood should be eosinophil. If this exceeds, then the conditions like headache, okay, straining of eyes, nose bleeding, all this occur. This is a response to the allergic reactions. Okay, next one is basophils. Okay, basophils are having a S Basophils are having a S-shaped nucleus, and obviously it is having a granular cytoplasm. It is having a granular cytoplasm. Coming to its characteristics, S-shaped nucleus, S-shaped nucleus, and it is responsible for, this is important, listen, it is responsible for production of inflammatory substances. Inflammatory substances. Okay. What are those inflammatory substances? There are three inflammatory substances that are heparin, heparin, histamine, serotonin, heparin, histamine, serotonin. Okay, what is the function of heparin? The function of heparin is it acts as anticoagulant. It acts as anticoagulant. When the blood is flowing in the blood vessels, then it does not form clots. Only when there is wound, it will be forming a clot, right? So why is it not forming a clot inside our body? Because in our blood we are having a heparin, which is nothing but anticoagulant. Next one, histamine. Histamine is a vasodilator. What is a vasodilator? Vaso means blood vessels. This is the thickness of, or this is the diameter of blood vessels. When this histamine is released, then the blood vessel diameter also dilates. That is because of histamine, so it is a vasodilator. Serotonin is exactly reverse, vasoconstrictor, vasoconstrictor. If this is the thick diameter of the blood vessels, on the release of serotonin, it will constrict, means the diameter will be decreased. These are the inflammatory substances, which means which are causing inflammation. These are the inflammatory substances which are released by basophils. Is it clear? Are granulocytes clear? Yes or no? Yes or no? Yes? Okay. Now these granulocytes के बारे में general point I am writing it over here. Okay. I'll write with red. Okay. Granulocytes are produced in bone marrow. They are produced in bone marrow. Okay. And their lifespan is lifespan is 4 to 5 hours. How much is their lifespan? Only 4 to 5 hours. Is it clear? Serotonin vasoconstrictor means blood vessel ka diameter is reduced. Got it? So are these responsible for formation of pimples? Nana, pimples one day of this CBC, no? Last में, facts में, I will be telling you about pimples for sure because all of you are actually teenage, right? So you must be facing the problem of this acne. What are the various causes of this acne? Because pimples are not having only one particular reason. There are diverse reasons for pimples. So one particular day I will be telling you for sure about these pimples. Got it? Nana. Vasodilator. Okay. This is histamine. Understood? This is histamine. Shall I? This one, you are asking about histamine, Shagufta. Are you asking about this second word? Yes. Just a sec. I will erase it. Oh. Okay. Vasodilator means increases the diameter of blood vessel. Vasoconstrictor means what is vaso? Blood vessel. Dilator means dilate, matlab increase. Constrictor means contract, matlab decrease. Easy to understand now? Fatima, did you understand what is vasodilator? Blood vessel dilation, vasodilator. Blood vessel constriction, vasoconstrictor. Okay, I will write this term also actually once again. Vasoconstrictor. Okay, vasoconstrictor. Understood? Now shall we move to agranulocytes? Shall we move to agranulocytes? No, no. However, see, when I am explaining, these are completely new terms for you. So, when I am actually reading it, introducing you the terms one by one, it will be little difficult. But when I complete this entirely and explain, it will become easy. For now, try to understand at least 30%. When I'll explain it for whole, you will understand 100%. Try for now you learn at least 30%. Got it? Ma'am, granulocytes are produced in bone marrow. Yes, they are produced in all blood vessels, all blood cells, bone marrow only. Okay, Shagufta, all blood cells are in bone marrow. But ma'am, lifespan of leukocytes is 6 to 7 days, but granulocyte is no. Leukocyte may we have granulocytes also, agranulocytes also, na? Right? Okay, leukocytes in total it is 6 to 7 days. Understood? But these granulocytes they die actually in 4 to 5 hours only. Okay, ma'am, please explain inflammatory substances again. Fine. Inflammatory substances are released by basophils. Okay, now what is this basophils doing? I told you now we have to stain, right? I told you we have to stain the blood to see the different components of blood. Okay, now these names are because of the stains. Understood? Neutrophils, it does not take any stain. We have two types of stains, acidic stain and basic stain. Okay, some take acidic stain, some take basic stain, some do not take any stain for us to see. Okay, neutrophils, neutral, matlab no stains are being taken. We add acidic stain, we add basic stain, both of them will not be taken by the neutrophils. Eosinophils, which are also called as acidophils, the name itself tell you it will be taking acidic stain. I put an acidic stain, then it will absorb acidic stain. When it will absorb this acidic stain, I can visualize it under a microscope. Next, basophils. Basophils will be taking basic stain. They will not take acidic stain. It will take only basic stain. That is the reason why it is called as basophils. Understood? Okay. Now, these basophils are least in blood but have a very big function. The least quantity is 0.5 to 1 percentage, but they have a very, very important function, that is they produce inflammatory substances. What are those inflammatory substances? Heparin, histamine and serotonin are those inflammatory substances. Heparin, matlab anticoagulant, which does not allow the coagulation, the clotting of blood inside the blood vessel. In our blood vessel, we do not have the coagulation of blood. Only when we have a wound or injury, then only the blood gets clot. Right? Inside our body, it is continuously flowing in the liquid state. Why? Because it is having something called as heparin, which does not allow it to get coagulated. Next one is histamine, vasodilator. So here if somebody has asked me a question, what is the purpose of histamine and serotonin? Okay, okay. Let me tell you it very clearly. Suddenly, okay, all of a sudden your blood pressure increases, BP increases. Okay, when this BP increases, then your body will show certain changes to alter the condition and bring them back to normal. Got it? Now what is that condition? When blood pressure, what is blood pressure? The flow with which it is moving into the blood vessels is what is called as the blood pressure. Understood? Now it is flowing very, very fast. Okay, think a pipeline. Understood? A pipeline, we have a thin pipeline. When the fluid, or you can say, when I say water, it is fluid blood in our body. When I say pipeline, it is nothing but blood vessel. Okay, now you people compare it. When this water is trying to flow through the blood vessel, or when this water is trying to flow through this thin pipeline, it is showing more pressure, right? 1 liter of water is trying to move through this thin pipeline. So what is happening? It is flowing with very high pressure because it wants to go through it. It is flowing with very high pressure. Now what did I do? I replaced this pipeline and I took a bigger pipeline with a big diameter. Understood? Then the water can flow easily. So, when the blood pressure inside your body increases, this histamine will be released by your body so that the blood vessels dilate and the blood pressure comes to normal. Did you understand? Did you understand, Samudra? Yes or no? Opposite happens in serotonin. Okay, when the blood pressure is very low, the blood is moving very slowly through the blood vessels. Okay, then what will happen? Reverse. The blood vessel will get constricted so that the blood moves with very high pressure. Okay, मतलब high pressure नहीं, blood pressure will be brought to normal, from low to normal. Is it clear? Zavia Sabine, the previous notes were already being sent to you people. Samudra, did you understand what are these inflammatory reactions for histamine and serotonin? What is the vasodilator and what is vasoconstrictor? Did you understand? Okay, good to know. Understood? See, our body is such a beautiful creation. Understood? Now, moving on to agranulocytes. Once I complete, because I want to complete today thrombocytes also. Don't you people want to learn about heart? If every day I will be teaching only this, then when will we learn heart? Next topic is heart, which is interesting. So let me complete this. Okay, no, when I explain it at a stretch, no, you will understand for sure. Even though if you are not understanding there, then I will clarify your doubts. Got it? Next, agranulocytes means clear cytoplasm. Agranulocytes means clear cytoplasm. These agranulocytes are of two types. These agranulocytes are of two types. What are the two types of agranulocytes? Number one is lymphocytes. Number two is monocytes. Okay, lymphocytes is 20 to 25 percentage. Monocytes is 6 to 8 percentage. Okay, coming to the lymphocytes, these lymphocytes are having large these lymphocytes are having large central nucleus. Okay, big nucleus, and obviously the cytoplasm is clear. I want to show you this as nucleus, so I am shading it. Okay, cytoplasm is not having any granules like this, so it is having clear cytoplasm. So what am I writing? It is having clear cytoplasm, obviously, and it is having round large nucleus. Round large nucleus. It is of two types. What are those two types? T cells and B cells. What are those two types? T cells and B cells. Okay, these are helpful for providing nothing but immunity. Okay, they are providing, just let me constrict everything. T cells and B cells for immunity. Okay, got it? Moving on next to monocytes. Monocytes also have a clear cytoplasm. Monocytes have a kidney shaped nucleus. Monocytes have a kidney shaped nucleus. Okay, kidney shaped nucleus, and it is also responsible for phagocytosis. It is also responsible for phagocytosis. Okay, so out of the whole blood composition, if I ask you which cells are responsible for phagocytosis, then what will be your answer? Neutrophils, let me mark it with red, neutrophils and monocytes, both of them are responsible for phagocytosis. You can see it, phagocytosis, phagocytosis. Is it clear? Okay. Phagocytosis is nothing but like eating process like amoeba. Any foreign particle, WBC is policeman, it will act against any foreign particle. If a foreign particle is entering into your body, then what will happen? This monocytes and neutrophils will open a big mouth, engulf this food particle or the foreign particle and kill it, destroy it, so that that foreign particle does not cause any disease. That is what is called as phagocytosis. Is it clear? Is it clear, Nana? Okay. So I will be explaining about the entire leukocytes. Before I explain about entire leukocytes, you should also know agranulocytes are also formed in the bone marrow. Okay, agranulocytes are formed in the bone marrow. Monocytes, lymphocytes, both of them are formed in the bone marrow. Monocytes can survive up to few months. Okay, they can survive up to few months. Okay, whereas lymphocytes can survive up to few months to years. Few months to years. Okay, it can survive up to years as well. Immunity, no? We can have immunity for longer period of time. Shall I explain the entire leukocytes once? So moving on to entire leukocytes, you should be learning leukocytes is nothing but white blood corpuscles which acts as the policeman of our body. Coming to the count, it is 6,000 to 8,000 per cubic millimeter and the lifespan is just 6 to 7 days. Based on the cytoplasm, whether it is having granules or not having granules, it can be classified into granulocytes and agranulocytes. Granulocytes will be having granular cytoplasm, which can be further classified into three on the basis of, I'll write on the basis of over here, on basis of stain, on basis of stain. Okay, if it is not taking any stain, it is called as neutrophils, which is 60 to 65 percentage. The nucleus is nothing but multi-lobed, many lobes are there in the nucleus, and it is responsible for phagocytosis. Okay, next eosinophils is only 2 to 3 percentage. It is taking up acidic stain. It is responsible for the allergic reactions, and it is having a two-lobed nucleus. Only two lobes will be there, 1 and 2. Okay. Last but not the least, basophils is 0.5 to 1 percentage, which is having S-shaped nucleus, and it helps in the production of inflammatory substances like heparin, responsible for anticoagulation, histamine for vasodilator, serotonin is nothing but a vasoconstrictor. Agranulocytes is having a clear cytoplasm, matlab there are no granules in the cytoplasm. It can be further classified into lymphocytes and monocytes. Lymphocytes is 20 to 25%. It is having a large central nucleus and is responsible for immunity because it produces T cells and B cells. What are those? For now you don't require. Remember, those are nothing but immunity providing cells. Okay, next one is monocyte, 6 to 8 percentage, which is having a kidney shaped nucleus and is responsible for phagocytosis. Lymphocytes and monocytes, both of them, they are formed in the bone marrow, but lifespan differs. Monocytes are alive only up to few months, but lymphocytes are alive from few months to many years. Is it clear? Now monocytes and neutrophils do phagocytosis. The others do not defend the body by phagocytosis. How do they? See, ma'am, a question arises in my mind that how that, what? Rangan, try to ask the question again. I did not get you. Samudva, okay. Nana, they are providing immunity to the whole body. Okay. Now, see, suppose I enter into the class. I am a foreign particle. I am giving an example. I am a foreign particle. Okay. Or you see, we have a work assigned. Understood? We have someone coming into the class. Okay, let us say this only. We have an inspection of our class. We are inside the body. All of us are blood cells. Okay, think about a classroom. Understood? We all are blood cells. I am leukocyte. What am I? Leukocyte. You people are granulocytes and agranulocyte. Okay. There is an inspection or there is someone who is coming into our class. Understood? Now, what I will do? I will divide the work. What I'm supposed to do? I will divide the work. Okay, so I am dividing that if we come to know that it is the someone who is coming is a terrorist, forget about inspection, is a terrorist, we have to kill him because I am leukocyte. I have to produce my soldiers, right? I have to kill him. So what I'm supposed to do? I will activate my neutrophils and monocytes. I will activate in the class, I will activate neutrophils and monocytes and tell them you first kill. Okay, by the action of phagocytosis. Engulf them and kill them. Understood? See, it is division of work. It is helpful for immunity throughout the body. The functions are being divided. Got it? Okay, thank you. Yes, now moving on to thrombocytes. Okay, now when I talk about thrombocytes, thrombocytes में इतना content है ही नहीं. Oh sorry, thrombocytes does not have this much of content. Okay, thrombocyte. Oh no. Thrombocytes. I am giving the facts over here only. Thrombocytes. Okay, thrombocytes are nothing but platelets. They are nothing but platelets. Okay, very simple. There are large cells in the bone marrow. These are cells in bone marrow. These are cells in bone marrow. Okay, these cells are called as megakaryocytes. These cells are called as megakaryocytes. Okay, now when there is irregular breakdown of this megakaryocyte, when there is irregular breakdown of this megakaryocytes, then we have this produced, okay, irregular shaped cells which are nothing but platelets. Irregular shaped cells which are nothing but platelets. Okay, platelets may we remember only 2 points in extra. Point number one, we should know the count. The count of platelets is 1.5 to 3.5 lakhs per cubic millimeter. Coming to its lifespan, the lifespan is 10 days. The lifespan is 10 days. Okay, what is its function? Its function is clotting of blood. Its function is clotting of blood. That's it. That's it about thrombocytes. Is it clear, Nana? Okay. Is it clear or not? See, dear chaps, when notes are being sent to you, you can be attentively listening in the class. Understood? Platelets are alive or dead cells? Obviously alive. Alive cells. Okay. Now coming to the most interesting part of our class, that is nothing but facts. है ना? Today, because we have completed the content, concept, we have completed the concept of blood, I will be telling you some facts about blood only. What say? Are you ready? Are you ready? Zavia Sabine, you will be receiving the notes only if you are there in the class. Till the end of the class, then only the notes will be shared, or else the notes are not being sent. Understood? Okay? Yes. So, I was talking about the facts about blood. है ना? So, how many liters of blood do we have in our body? In our body, we have 5 liters of blood which is continuously circulating, Okay, it is constituting 7 to 8 percentage weight of your body. Whatever is the weight of your body, 7 to 8% weight of your body weight, okay, 7 to 8% of your body weight is because of blood. It is because of blood. Understood? Okay, got it? Yes, now our body, because we are having a closed circulatory system, our body has blood vessels. What does it have? Blood vessels. These blood vessels, if I try to arrange all the blood vessels of a human being in a straight line, it will be covering 1 lakh kilometers. It will be covering 1 lakh kilometers. Good. Okay, all the blood vessels of the body, human body, if they are arranged in a straight line, it will cover a distance of 1 lakh kilometers. Okay, one more fact, RBC, you know RBC, circulates in our blood, right? RBC completes the circulation of our body, circulation in our body in just 20 seconds. One RBC completes the entire circulation through all the blood vessels in our body in just 20 seconds. How many seconds? 20 seconds. Okay, now because we know about the different formed elements, I will be telling you about some of the disorders. With those disorders, you should be knowing what you should be eating for keeping yourself healthy and keeping your blood also healthy. Understood? Okay, so what do we know? I'll write over here because otherwise you'll forget. Formed element, na? Formed elements. What are the three formed elements? The three formed elements are RBC, WBC and platelets. Okay, this is the fact of day. Understood? So, in RBC, okay, in RBC, if there is increase of RBC, the condition is called as poly. If there is, I'll write from here, increase of RBC, the condition is called as polycythemia. The condition. You have become doctors now, so you should know these terms. Polycythemia. Your blood will become very thick. If the RBC count increases in your blood, then your blood will become very thick. It should be having only 5 to 5.5 million count. Understood? If there is reverse decrease of RBC, then it is called as, we are very familiar with this term, that is anemia. That is anemia. Less iron in your body. Iron, where is iron present? In the RBC. If RBC count decreases, automatically iron content in the body will decrease. Iron content decrease means anemia. Okay. Next, moving on to WBC. Increase of WBC is called as leukemia, which is nothing but blood cancer, which is nothing but blood cancer. Decrease of WBC is called as leukocytopenia. Okay, leukocytopenia or leukocytosis it is called as. When there is decrease in the WBCs, what exactly will happen is your body cannot fight against any type of disease causing microorganisms. But when there is increase also, it is not good. It should be 6,000 to 8,000 only. If it is abnormally increasing, it is causing blood cancer. Understood? Next, moving on to platelets. Increase in platelets. I am not writing the word. Increase in platelets is thrombocytosis. Decrease in platelets is thrombocytopenia. Thrombocytopenia. Okay, what is the function of platelet? Platelet is causing coagulation, clotting of blood. If the platelet count increases, then inside the body also it will form clots. Understood? That condition is called as thrombocytosis. If the platelet count decreases, even if you have a wound, it has to get clot. But because the platelet count is less, there will be excess loss of blood bleeding from your body, and the condition is called as thrombocytopenia because it will delay the formation of clot. Is it clear? Are the terms clear? Yes. Okay, champs, that's it. Thank you. So I hope you must have understood about the different types of formed elements. Notes will be shared, which will include the fact of the day as well. Okay. And Samudwa mentioned the point diapedesis. I will tell you about that point. WBC is having a special quality. WBC can squeeze through the blood vessels and come out. RBC cannot come out because it is having a definite shape. But WBC from the blood vessel, it can squeeze and come out. That condition is called as diapedesis. Okay? Thank you, champs. So we'll get back in tomorrow's class with the topic heart, because heart is the one of the circulatory component. So we'll be learning about heart in tomorrow's class. Thank you, students. Champs, wait for a minute till you get the notes. Okay, don't exit. As soon as I say bye, don't exit. Wait for a few minutes till you get the notes. You'll be getting the notes. Okay, yes, it's being sent. Just wait for 2 to 3 minutes. It will come.